My name is Jack Rowley. I'll be your host for the day. I lead the GSMA EMF issues. I see many familiar faces around the room, and I saw many familiar names online, but also some new faces. And everyone, whether first time or 14th time at an EMF forum, is welcome for today. A couple of other things before we turn over to the main first speakers. I'll answer a question that we always get. Yes, the presentations will be available after the event where we have the agreement of the speakers. Yes, the recordings will be made available as soon as possible after the event, again, where we have permission of the speakers. We do encourage discussion. One of the reasons that GSMA established the EMF Forum was to be a platform for dialogue between all the stakeholders involved in the EMF issue, academic, regulatory, policy, and industry. And so we encourage you, those in the room and those online, to contribute questions throughout the day. And we've tried to structure the program to allow many opportunities for that discussions. We'll also have a few polls through the day using Slido, where we'll give an opportunity for people both in the room and online to share their views on a few points that we hope will in turn inform some of the discussions in the panel sessions. Let me see. Oh, one last thing. For those who are in the room, there's some QR codes in the back of your badge that gives you a link to the program for today. So if you're trying to check where we are in the timing and what speakers are coming up next. And there's also a link to a GSMA report that we will be launching shortly. With that, I will open up the first formal speaker of the day, which is Mike Wood from Telstra and chair of the GSMA EMF and Health Group, to give some opening remarks and welcome to the EMF Forum. Can we bring Mike up on the screen, please?
Good morning, Jack. I wonder if you can hear me okay.
We can certainly hear you, Mike.
That's fantastic. Okay, well, look, I'd like to echo Jack's comments and remarks about the forum. I think we're into I think this is the 14th EMF Forum now. So on behalf of the GSMA's EMF and Health Group, thank you all, especially to the participants that have travelled to Brussels. I'm usually there in person, but for family matters, I'm here in Australia. So it's the afternoon on Tuesday here. So I'll get to experience what all of the online participants experience, and I'll be keen to participate in the Slido polls and contribute to the conversation through the chat or however we can ask questions. These events are fantastic in terms of sharing information, and being the 14th one now, we get a lot of the same people at the event, but also some new people, and I really encourage the new people to get involved as much as you can. Thank you to all of the speakers, and especially the steering group that have come together from the GSMA to make this event possible. Things like this aren't possible without everybody contributing a little bit, and that's what we've found. Being able to get this event up and running, I really wanted to thank all of the speakers and the steering group for making this possible. Look, technology is evolving, and the tagline or the theme for the event today is the evolution of EMF science, technology, and communications. I think we'd all be, we're all familiar with the accelerated growth of the wireless technology. We're also familiar with all the challenges that we have in terms of ensuring that it's safe and ensuring that we do the research, we understand the research, and we understand the technology that's coming ahead. So there's a number of sessions today that look at the current health research aspects. But I'm particularly excited for one that's towards the end of the day. It'll be quite late in the evening here in Australia, where we look ahead at the future technologies and what's on the roadmap ahead and everything in between. To that end, we'll have expert speakers addressing the latest EMF research and risk assessment. And as I mentioned, the evolution of the mobile technology. But of course, when we roll out and deploy these technologies, effective communication is really important, and we've got a session today that looks at the approaches of different countries, and I'm really looking forward to that session. As always, the aim is for dialogue in these events, and we really encourage those, as I mentioned before, online and in person in Brussels to contribute to the discussion. Look, without any further ado, Jack, I'd like to officially open the event. I'm looking forward to it. I'm looking forward to seeing how it works online. And I'll pass back to you, Jack.
Thank you very much, Mike. And sorry that you couldn't be here. I think you would have been able to mark your card for the 14th EMF Forum if you had been able to.
Well, I'll still mark it, Jack, but it'll just be a remote card. Thank you.
Thanks, Mike. So with Mike's opening remarks, I'd like to invite Laszlo Toth, my colleague as head of Europe and the CIS region at GSMA, to give some introductory remarks and a European perspective on the topic. Laszlo.
Thank you, Jack. Thank you. Good morning, everyone. Welcome to Brussels. Welcome to the GSMA EMF Forum in 2025. For over a decade, we've been organizing this unique forum. We bring together scientists, policymakers, and industry to discuss EMF science, policy, and communication. And I'm very happy to be here again and participate in this great forum. The expertise in the room is key. Together, we can bridge the gap between complex research and concerns of the citizens. Together, we can ensure that science not only guides policymaking, but earns public trust. Today, we welcome participants from all over the world, and as we come together, it is essential that our discussions reflect also global challenges over time, including polarization, disinformation, trade tensions, global tech race. We cannot talk about EMF issues in isolation, I believe. As we know, the evolution of 5G and related wireless technologies is not just a technical achievement, it is a catalyst for societal progress, innovation, and economic growth. However, with these advancements come important questions and responsibilities, and this is why we must continue having evidence-based discussions. This is why it is essential to ensure that the latest science is heard, understood, and used to address public concerns about EMF and future technologies. This forum has always been very international, but I would like to take a moment to share a few thoughts on the European context. In Europe, we are at a turning point. Bold digital ambitions face real challenges, underfunded infrastructure and barriers to network deployment. The upcoming Digital Networks Act, expected this December, is a chance to rethink how networks are built, funded, and used, because 5G and soon 6G is not just about speed, it's the foundation of Europe's ability to compete, innovate, and lead. Unfortunately, lack of harmonization of EMF limits and EMF assessment procedures continues to be a barrier to efficient network deployment and fosters concern among the public. Having said that, I must acknowledge that the European Commission has been true leader. It was amongst the first organizations to make it clear that international EMF limits also apply to 5G, providing regulatory certainty at a crucial moment to network deployment. The Commission has also been at the forefront of combating 5G misinformation on social media, a challenge that remains critical as Europe prepares for 6G. And beyond regulation and communication, EU-supported research continues to play a vital role. The Clue Age projects funded by the Commission will provide essential information for risk assessment groups and policymakers, helping to ensure that any decisions are grounded in robust evidence. We are also pleased to see that the Commission is supporting forward-looking 6G initiatives, such as the 6G for Society, which address societal acceptance and public understanding of all accept, including EMF. Building trust and transparency around emerging technologies is crucial for their successful adoption. And regulators across Europe are reinforcing this approach. Both BEREC and the RSPG have highlighted the ICNIRP guidelines as key to ensuring transparency, scientific rigor, and the protection of human health. Several member states have already adopted the ICNIRP 2020 as a basis for assessing base station antennas, a positive step towards harmonization across the EU. Together, these efforts show that Europe is not only advancing in technology, but also setting global benchmark for responsible, science-based and socially trusted digital transformation. But let me close with this thought. Connectivity is not just about networks, it's about people, about ensuring that citizens, businesses, and the communities have tools they need to thrive. And science and evidence must remain the foundation of our decisions. Both science alone is not enough. We also need the right policies, the right incentives, and the right dialogue between industry, researchers, and policymakers. And before I finish, I wanted to take this opportunity to thank the steering group members from the GSMA, EMF, and Health Working Group, and the supporting GSMA staff for their hard work for preparing today. We also thank the speakers for agreeing to share their thoughts and insights. And as a goal of every GSMA EMF Forum has been contribute to improved understanding and sharing of good practices. I know you will find the discussions today informative, and I wish you a successful day. Thank you.
Thank you, Laszlo. So we thought at this point in the day that it might be an opportunity to maybe give you some insight into why we've set up the program today by reflecting a little bit on what's happened since we met in this very room in October last year. At that time, the theme of the event was the learning from 5 years of commercial 5G deployments, and we highlighted 5 points: that the 5G rollout had been quite rapid, that at 5 years post-launch there were about 3 times as many connections as a proportion of total connections in 5G as 4G was at the same stage. We just had the updated ICNIRP guidelines launched in 2020, and that they were applying to all frequencies used by mobile communications, as Laszlo mentioned, and we'd seen some momentum for their adoption building. We'd also seen updated EMF assessment methods that gave us more accurate approaches to looking at particularly active antennas, and this is something that we'll come back to in terms of wanting to encourage greater adoption by regulatory authorities. At that time, we had seen measurements in 35 countries, all of which demonstrated that the typical levels from 5G were very similar to existing mobile technologies. And this is what we expected, but it was counter to the narrative that was being promoted by anti-EMF groups before 5G was launched. And we had the continued consensus that provided you comply with those international EMF limits, there were no established health risks. If you want to recap the events from last year, you can access the slides and the recording at the URL on the screen. We've also seen expanded ICNIRP adoption. As of this weekend, when I was updating these slides, about 30 countries have either adopted ICNIRP 2020 or marked it on their roadmap as something that they are planning to update in the near future. I've got a question mark for Europe in ICNIRP 2026. As was mentioned by Laszlo, there is an outstanding recommendation for the European Scientific Commission, SURE, calling on the Commission to update the Council recommendation and the Worker EMF Directive to take account of the ICNIRP 2020 guidelines. And I put a question mark on Europe because I am hopeful that we might see some action on that in 2026, and we certainly want to encourage that. We've also seen since the last EMF Forum the publication of Edition 4 of IEC 62232. That was a major focus of the event when we met last year, and we had some very informative presentations giving a preview of what the content would be. And those speakers stressed the technical continuity and consistency of work between both the IEC standard and the ITU recommendations. One of the things that Edition 4 of IEC 62232 does is it provides much greater clarity on the implementation of the actual maximum approach, and that in turn delivers greater accuracy in EMF assessments for base stations with beamforming antennas. We're now awaiting the companion IEC technical report 62669 with implementation case studies, which is, I understand, expected to be published in early 2026. It's going through the final phases of editorial work at the moment. And again, GSMA encourages more countries to allow the use of these advanced and modern methods to assess base station antennas. If you want a recap and a summary of what was in those two standards, you can watch these videos from our EMF Forum last year. And for those of you who are here in Brussels, the presenters of those sessions are here, so you can approach them and ask them questions directly. So please do that. Take advantage of that. I mentioned that last year we had 35 countries who had produced 5G surveys using methods similar to the 62232. That's now gone up to 37. We've added some new countries, including Slovenia, which had 5G private networks in building survey being published. And we've also got several new studies from previous countries. For example, in the UK, the health agency did quite an extensive national study measuring 5G. And we continue to see, across all the 5G bands, maximum levels at about less than 1% of the international public limits. That's sort of the technical stuff. We have quite a bit of the focus today, this morning in particular, on the science. And there is a continuous process of RF EMF risk assessment. This has been happening even before we started talking about mobile networks. We have a very large body of scientific evidence across the whole EMF spectrum, but also specific to mobile communications. And we are having, that continues to be informed by new projects. Last year, we had an update from the Commission-funded C-Wave project. This year, we have Goliath giving us a similar update, and we look forward to hearing about the progress of that and how that will inform future risk assessments. Since we last met, at least 3 national expert groups of which I'm aware, Austria, Sweden, and from Switzerland, have done risk assessments and published reports. Overall, these reports conclude that the international guidelines appear to be still protective, but there are differences in emphasis, and some of them suggest that there might be needs for additional precautions or greater uncertainty, or emphasize greater needs for further research. And that's one of the reasons why we have the panel today, where we have representatives from 2 of those expert groups who can talk about how expert groups review the science, how they track it, and why, in some cases, they have a different reading of where that consensus is at. And that's about ensuring that there's good understanding of how EMF risk assessment occurs. Speaking of EMF risk assessment, we're all, I think, waiting for the WHO task group on radio frequency fields and health to report. When we had the presentation from Dr. Van der Venter from the WHO last year, we were hopeful that we might have it this year. I'm waiting to see in the presentation today whether it will be in my Christmas stocking for 2025. And we're looking forward to the presentation from both on behalf of the WHO task group and also on behalf of 2 of the important systematic reviews that contributed and inform as inputs to that task group activity. One of the misunderstandings that I consistently see is that the idea that because we've had mobile networks that continue to expand, that exposures have also increased. And this is data from a Goliath and Attain, 2 European Commission-funded projects paper that was published earlier this year. And you can see over the period 2016 to 2023, based on measurements done in a selection of European countries, despite the fact that mobile data increased by 8-fold, exposure levels didn't really change very much at all. And that's something we've seen previously. The transition from 2G to 3G, 3G to 4G, and 4G to 5G has not really changed significantly exposure levels. And we will, when we talk about 6G later in the day and what the mobile technology revolution roadmap looks like, we'll have some insights perhaps into what that might look like going forward. And we look forward to the presentation from Goliath giving us some more insights into their activities. science is necessary but not sufficient. Every time we have organized these EMF forums and we look at the feedback, we get requests for two elements. One is to continue to provide an update on what is happening with the science, and the second is to share good practice on addressing public concerns, particularly around base station siting, and how to communicate effectively. This is a study from the Netherlands, published earlier this year, where they interviewed stakeholders representing all the major groups in the country, so government, industry, and concerned groups. And they found, as you can see here, that there can be a tendency when looking at the science for different groups to think that their reading of the science is the only correct reading. And the science on its own becomes a point of contention rather than a point of reaching consensus. So I'm really looking forward to the presentations today, where we'll have looking at an international comparative study of risk perceptions across 3 countries, Poland, Germany, and Japan, where we'll see both similarities and differences, and it will be intriguing to try and guess at why those differences and those similarities exist. We will also have a very experienced panel of industry professionals who have been dealing with the EMF issue through many generations of mobile technologies, who can talk about what they feel has worked and maybe something about what they feel does not work when engaging with the public. Now, maybe looking a little bit to the future, the latest data from GSMA Intelligence suggests that we may have already reached peak 4G connections, and that 5G growth is where we're going to look at in the next number of years. That transition to 4G and 5G in countries is likely to accelerate as we see more closures of 2G and 3G networks, freeing up that spectrum for more modern mobile technologies. But that should not make us miss the significance that 4G and 5G will be the main technologies moving into the 2030s. There is still a lot of life in those technologies yet, and it can be premature to think about transitions. It's also clear that all these transitions are gradual. They don't happen in a step change as we talk about new technologies. I mentioned that QR code for those in the room, so we're launching today our new Mobile Technology Evolution Report. This is around that theme of the event today, the evolution of EMF science, technology, and communication. And this is in the context that we always wanted to see accurate information provided about exposure from mobile networks. We published our first report on 5G in 2017, so it seemed at this point to be the right time, and particularly taking the lessons from our event last year, to start looking forward. And I really want to thank also the members of the GSMA EMF and Health Group that inputted to the development of this report. In some ways, the future is already here. There's a lot of discussion within the mobile industry about integrating satellite direct-to-device or D2D services as a supplementary coverage solution to terrestrial service in remote areas. Depending on the licensing arrangement, that might be done through direct dedicated satellite spectrum, or it may be done by sharing spectrum with local operators through commercial agreements. Most of these D2D services initially are based around text or low data rate IoT type applications, but we're starting to see some voice-based solutions coming into the market. Some of these will use unmodified handsets. And the data that we're seeing so far is that the received signal strengths that the devices are similar to what you get on a terrestrial network near the edge of the cell. And so correspondingly, the device powers are limited to the same they would have in a terrestrial network, and means they have to comply with the same safety limits. We're also seeing the availability of additional mid-band spectrum, which is necessary to support the continued growth of mobile network and support data demands. And there's some talk about, particularly in the academic community, about higher frequencies, the so-called sub-terahertz bands. But I want to emphasize today that they are not on any of the technology roadmaps from 3GPP or ITU. So we're not talking about them as being the bands which 5G will evolve into or 6G might occupy. Regardless, again, the international limits apply to all those frequencies. So each generation of mobile technology has given us new capabilities. You can see some of those on the slide today. Sensing is the aspect that's talked about quite a bit in the 6G discussions in various forums, where they will use the radio frequency signals from the network to inform about the physical environment. I'm interested to understand better how that will actually be implemented. One of the feedbacks from a 6G workshop earlier this year was the desire that 6G be very much an evolution of 5G, and that it should require minimal new hardware. In many ways, ideally, would be a software upgrade for the networks. Our final session today will look at, from an EMF perspective, what the technology roadmap looks like. Before I turn over the first session to Manfred Ruttner, who's the Deputy Chair of the GSMA EMF and Health Group, and with A1 from Austria, again, I want to reinforce the thanks that other speakers have done to all the people who've contributed to make today a success, and your contributions by way of questions and inputs will help us to do that. So with that, Manfred, I'll turn the first session over to you. Thank you.
Thank you, Jack, and a warm welcome to you all also from my side. For me, it's an honor to be the facilitator for the first part of this GSMA EMF Forum, because it's about a very important issue, because it's about the WHO assessment of health effect of exposure to RF EMF. We aim to address the EMF reviews, which are intended to form the basis for the upcoming environmental health criteria for high-frequency fields. We will hear about the history and the current status of the reviews and the work on these reviews. We have two guests, Dr. Jos Verbeek and Professor Martin Rösli will provide us with their insights. Please hold your questions until later. After the presentations, we will have a Q&A session where we can take the time for the questions to the two speakers. We will start with Professor Rösli. He is a full professor for environmental epidemiology at the Swiss Tropical Public Health Institute in Basel and leads the environmental exposure and health unit. His research focused on various environmental health topics with focus on electromagnetic fields exposure and noise. So I invite Martin Rösli to the stage. The stage is yours.
Good morning. It's a very pleasure to be here, and thanks a lot for inviting me and give you an overview of the WHO reviews where I've been involved. So basically, through 3 reviews I will mainly talk about. There were quite some people involved in this review that also contributed to them, so they are all listed here. And I would like to emphasize also Ken Karipidis, who also sent me a few slides of his presentation he gave at the BioEM in Rennes this year, so I could profit from his work in this presentation as well. Just to look back how it started, in 2011, IARC has done the cancerogenity assessment. I was involved in that, and shortly after that, the plan was to write the EMF monograph, the so-called environmental health criteria. And I was also asked to participate in the epidemiological chapter, and I agreed to do that. We were 4 people under the lead of Maria Feichting. And then we had done a first draft. After 1 year, we thought, okay, job is done. Soon everything will be published. But actually it took a bit longer, and then we had a first update, the second update, the third update, and the fourth update of all these studies. And it's still not published yet. I think it's now labeled the scoping review and should soon be published, whatever soon means in that context. Anyway, since I was involved in this scoping review, I thought, okay, it's not a lot of work to do this systematic review. When there was a call, let's do that. So I applied with my team for 2 reviews for the symptoms, human experimental and observational studies, and also participated in the cancer review. But also here, it took much longer than anticipated. It was much more work than anticipated. And basically, as you know, it almost became 25 until all the reviews are published. And now it's a task group which is doing the final work, and looking forward to that one where I'm not involved. So how were the topics selected for this review? And maybe Jos will talk a little bit more about that, but basically it was a survey among different experts of EMF. 164 of those asked have responded, and basically they have made a priority list based on different criteria like public concerns, human studies, animal studies, and so on. So for instance, electromagnetic hypersensitivity was considered an important topic from a public concern perspective, and so this was decided that this should be one of the review. And obviously cancer was also considered a very relevant topic. Here also, as a potential burden of disease was relatively high for cancer. If you are interested in the details, all you can see in the in the paper of Jos published in 21. So let's start with the systematic review 8, which is on human experimental studies on symptoms. So there has been first developed a protocol which can be read, which was transparently made public, and then the review paper which was published in 24. And what is the main reason for that? So here's the protocol and the result paper. When I started EMF research 25 years ago, my obvious thinking was, let's ask the people who claim to have problems. What are their problems? What do they experience? And this was one of these survey. We had asked 394 individuals who ascribe symptoms to EMF, and they mostly reported sleep disorders, headache, nervousness, and a lot of different symptoms. We also have seen that quite a large part of the population or of this group said they can immediately react if they are exposed. Within a few minutes they react, or in the next night they cannot sleep anymore. And this, of course, is a very good news from a scientific point of view, because this is feasible to be investigated in an experimental study. You cannot do experimental studies and expose people for many years, but you can do for a few minutes if you expect that they react immediately. By the way, we also ask whether they have symptoms due to other exposure conditions. And you see, it's not very uncommon to have symptoms because of environmental conditions like noise or air pollution. I mean, this is quite common. Actually, EMF is rather on the low side in terms of reporting symptoms because of it. So we followed in all these reviews, not only us, the so-called PECO approach. So PECO means population, exposure, comparator, and outcome. So the population for the systematic review 8 was that we were interested in volunteers with IEI. It's a very complicated word. I prefer the term electrohypersensitivity just to pronounce, just out of pronunciation. But IEI means idiopathic environmental intolerance attributed to EMF, but it's a very, very long one. But also in volunteers without claiming this type of problems. Basically, we looked into all kind of EMF, radio frequency EMF exposure, near and far field. In principle, we considered near and far field, but in practice, of course, near field meant in these studies almost exclusively exposure to the head from an antenna or from a mobile phone, mimicked mobile phone. So usually these studies express the exposure in terms of the SAR value. And environmental exposure was mainly a whole body exposure, so maybe the antenna was put a few meters away, like a base station, and the whole body was exposed. And typically these studies express the exposure in volt per meters or watt per meter squared, and we recalculated based on standard formula to SARS for our exposure response meta-analysis, meta-regression. So, okay, the sequence is not as I thought. Comparator, we only included studies that had at least one sham condition without any exposure, and one exposure condition, so that was the main thing. And in principle, we included all the studies for all type of symptoms. We were not restrictive in any terms of symptoms, but in practice it turned out that headache, sleep disturbance, and composite scores were the main symptoms that we looked at. And composite scores means that people had to answer a standardized questionnaire, like 20 items. How nervous do you feel? Do you feel agitated? Do you have difficulties to concentrate? And then people typically say not at all, a little bit, and so on. And then a whole score is calculated. And on the other hand, we also looked into studies that looked into the ability to perceive electromagnetic fields, because this is something a lot of IEI individuals tell to do so, and it seems also quite important for their annotation and for their attribution that they feel that they can perceive it. So here is the literature, the output of the literature search. So we identified 8,900 articles with our systematic search terms, and finally included 40 studies. And sometimes there's a misconception I've seen that people say, there's so much crap research, 8,900 and only 40 are good. But this is not because it's crap research, it's because it's very difficult to make a very clear search strategy for these keywords, because electromagnetic fields can be in any kind of article, can appear this type of keyword, and so you cannot do it very specific. So it's a lot of handwork, and that was also one reason why it needed a lot of time. You really have to go through all these records. Mostly from the title, it's very clear what to exclude, but some of them you really have to add on. If you want to see the detail and the exclusion criteria, they are all in the paper. What we have identified are mainly crossover design studies. So crossover means that the same person is exposed to several conditions, like a sham conditions, a low exposure, high exposure, and so on. And this is a very nice design, because then you don't have confounding from individual risk factors, because you compare the person with themselves. And that is also the reason why most of the studies have been like that. In other studies, if you look at clinical trials, they're often in parallel design. So it's part of you randomize people in exposed and non-exposed, because you have a long-term assessment, so it's not so easy to give some people a drug and then not the drug anymore. But here you really can do that, because you would affect a short washout period, and you can reinvestigate the same people again. And then we did a risk of bias assessment, where that was adapted to the aim of that review from the OHAT, a well-known tool. And this is just an example. You can, for each studies that we have included, you can find the reasoning why, what is the risk of bias of that study. Whether whether it was randomized, whether the exposure conditions was adequately concealed, blindness of exposure, attrition, how well the exposure was characterized. And you see, in this case, in this example, this was done very well, whereas little information was given about the randomization process. It's sometimes difficult. It does not mean that they have done it wrongly, but if you don't see the information, we usually give them some kind of probability of having bias. Here you see, for instance, for the outcome assessment, a very high risk of bias, and you think, oh, this research is stupid, they cannot do a proper study. But this is not the case in this example. This study had another aim. They looked into physiological effect, and symptom was just a byproduct. So they just asked people, did you feel anything or something like that, in a very unstructured way, which for our review is not very good. But of course, you can understand that if you have not this in mind, you just want to see whether maybe something went wrong with the blinding in the study or something like that. You may do such things, but this does not mean that, that the researchers didn't know what to do. It's just for that purpose of our study. And that's the purpose of a systematic review. You really want to include everything, even if it's not perfectly fit, but then you want to give more or less weight depending on the risk of bias. And then we did meta-analysis. So here you see an outcome. This is for all the experimental studies that looked in the general population, so not in IEI individuals, and looked into head exposure. The exposure ranged from 0.5 to 1.6 watt per gram. And then we calculated the standardized difference. So because often different scales were used to measure headache, all of them commonly used, we have calculated the standardized mean difference, which really refers to the difference between exposed and unexposed situation. And in this case, you see the mean difference increases by 0.1 unit, which is very little in terms, that's a tenth of a standard deviation, so this is almost nothing, and what was not significant. And then the next step, if we have done this meta-analysis for all the outcomes, you will find much more in the table. That was just an examples. We did a certainty of evidence rating, also using the OHAD approach. And basically, you start with an initial certainty rating, which was high for experimental studies, and which was moderate for observational studies, which I will talk later about, because there's more possibility of bias compared to an experiment. And then there are potentially 3 factors that can upgrade the evidence, or factors that can downgrade, like risk of bias in the studies, inconsistency, indirectness, imprecision, and publication bias. And then you end up at the end for each exposure outcome pair with a final certainty rating, which goes from high, moderate, low, very low. In our case, you can see the main symptoms. So you see on the top the general population experiments, and on the lower part of the table, 7 to 10 experiments in individuals. There's usually one set of studies for head exposure and one for whole body exposure, like for headache. Then sleeping disturbance, again, head exposure and whole body exposure, and the composite score. And you see, basically, for none of them, the meta-analysis turned out to have a significant effect. So we had absence of evidence for an association. And depending on the number of studies, the certainty was moderate to very low. So very low, for instance, was if there was only one trial, if it was in young adults, so it may be the indirectness was not very was scored -1 because this may not be representative for the whole population if you only look into healthy students and things like that. Then, in terms of EMF perception, this is just an example from studies where I've been involved on UMTS. Basically, you see how this works. So people work on, and I think this is similar to other studies as well. People sit there, there's an antenna, and they had to perceive, to say whether they could perceive the exposure and not, or not. And on the what is shown here in this meta-analysis is the ratio between correct hit and expected correct hits if you just do random guessing. So if the ratio is 1, basically it means it's equivalent to random guessing, which is actually what we observe for the general population. And we also see basically no improved guessing or perception for IEAE EMF individuals. It's slightly higher, so but it's not significant, so it can be chance. There's also a design effect, which is a bit difficult to consider here, because we have seen that IEI individuals tend to say more often yes, even if there's nothing. So in many studies, there were more exposure conditions than sham conditions. There was one sham, but maybe low, medium, high exposure, and so they, by chance, have, even if they say always yes, they have 3 times a correct hit. We try to adjust for that, but it's sometimes difficult if you don't know what the volunteers knew about the design of the study. So to conclude, we had 40 studies. It's quite well investigated. I think basically there's to a varying degree of certainty, there's no evidence for an association. Obviously, such an exposure condition situation is different from the general real-life situation, so that's an inherent limitation of this type of studies. And most of the studies only looked into young people, in students, so that's also a kind of limitations. We couldn't find any evidence that people who claim to perceive exposure can do that better than expected by chance. And then some studies, very interesting, they used open provocation. So they first said, okay, now we have exposure, do you feel something? And then people said yes, but in the double-blind setting there was no difference anymore. So a kind of positive control. Here it's now about self-reported symptoms and observational studies, so basically epidemiological research, also protocol. Let's put all on the table. So we looked into general population or in workers. There were no separate studies on IEI individuals, because you can imagine if they prevent and try to reduce exposure, you cannot really address that in an observational study. It would not work. So you would see that people with more symptoms have less exposure because it's a kind of reverse causality. They reduce exposure because they experience symptoms, and that would not work in an observational studies. We looked again into head exposure or whole body exposure, and basically most of the studies had a continuous exposure scale, so we looked into the association per unit increase and defined a priori 5 main hypotheses. We said tinnitus, migraine and headaches, we were mostly interested in relation to exposure of the head, mobile phone use in this case mostly, or cordless phone use, and sleep disturbance during night when people don't use a mobile phone, and general composite symptoms score to whole body exposure, which could also be personal measurements in some of the studies where they have 24-hour measurements. Sometimes it was modeling from base stations. The same procedure here, a lot of studies, a lot of screening. At the end, we ended up with 13 papers representing 9 different study populations. Here is an example, headache in relation to exposure to the brain. You don't see a significant association. Risk of bias, here an example. So this is from a nationwide study. They have very good outcome data. But on the other hand, which is a typical example in many cohort studies, in particular if they were made in the early phase of mobile phone uptake, the decision to start a mobile phone subscription or to use your mobile phone may depend on your disease status. So if you have a disease, you may say, okay, I'm most of the time at home, I don't need a mobile phone, or the other way around, I need one because if something happens, I want to have the possibility to call. So this type of reverse causalities is a typical issue in this type of early studies. Here another one, whole body exposure and composite score. What is very interesting, a few studies not only looked into modeled exposure, so this is also far field exposure, but they also ask people, do you think you're more exposed or less exposed than the general population? And what is interesting in these studies, so if they looked at composite or headache or sleep problems, if they used the modeled exposure, there was no real association. So you see, this includes the 0, so there's no association. But if they used the perceived exposure, then basically there was an increased association for this type of symptoms. And this may be a kind of nocebo effect. People think, okay, I'm exposed, maybe there's something on. Maybe it's just a general attitude of some people. They never thought about symptoms, about exposure. So some say just whatever you ask them, they say a little bit more than the average maybe. So you don't really know that. I think that's a real problem for this type of review, that exposure is self-reported. You ask people how much they use the mobile phone, and the symptoms are self-reported. I don't think self-reported symptoms per se is a problem, as usual. But if it's related to exposure, it's really a limitation. So that's part of the limitations in this type of research. On the other hand, we also see a lot of people don't really have a clue about their exposure situation. So if you really have objective markers like modeled exposure, it should work quite well. So here, basically, you see this observational research. There were a lot of factors that did a downgrading of the certainty of evidence, mostly because of exposure assessment, which is not perfect, which is very difficult to do in this situation. Then imprecision, and then the indirectness refers mainly to exposure from mobile phones, because in principle we are interested in radio frequency electromagnetic fields, but we measure mobile phone use, which comes with a lot of other things. You may consider that as confounding factors, but we thought, okay, we give this more the indirectness penalty, because it's very difficult to say which confounding factors for which hypothesis you really have to include. So we had for confounding relatively lax criteria. They only had to adjust for socioeconomic factors, for age and gender at the minimum. But then if they only looked into mobile phone use, then we gave a little bit more. Interestingly, some studies try to disentangle the usage from the EMF exposure for looking, for instance, separately in 2G use and 3G use. And all this type of attempts, there were also other attempts, they didn't indicate that EMF exposure is more problematic than just usage per se, or that this does not mean that usage per se is problematic, but they didn't see some kind of indication that really the exposure is relevant here. Okay, so in summary, there's a large study population, but there's very few studies. There's a lot of limitations inherently in this type of research, and mainly related to exposure assessment. And the other problem is really that mobile phone use is a lifestyle factor, and that we have to deal with something like the healthy communicator effect, like the healthy worker effect. People who are in the working population or people who communicate a lot are usually more healthy. They are just fit, and so that's an inherent limitation here. And then let's finally come to the cancer studies. Here we have two result papers. One is on the more researched outcomes, which is mainly tumors in the brain and around the brain, like also a salivary gland, and then the less researched outcomes. We had, in principle, three different PECOs. Two on the general population, one focused on near field, one on far field, and then the worker exposure. And depending on the PECO, we had different tumors which were considered to be critical, where there's more research, and all others were considered as important and were then in the second paper summarized. Again, you can look into the details. There's a lot of studies that has been to be screened. At the end, we had 147 articles included in the review. So there's really a lot of research on cancer. Again, risk of bias analysis we have done. So this is the main result related to glioma for every use. You see on the upper part the cohort studies, on the lower part the case control studies. And on average, the relative risk is 1.01, so this means no increased risk, which is with the significance, the confidence intervals including the 1.0. You may say, okay, every use is not the most sensible measure, so we also looked into people that had long-term mobile phone use. Long-term use means at least 10 years. And here we separated the studies by tier 1, which are studies that had low risk of bias, compared to studies tier 2, which had a medium risk of bias. There were some concerns there, and it can be seen that with the better quality studies, there was no associations, whereas for the other studies, it tended to report higher risks. So to summarize, we have moderate certainty evidence, so we have really a lot of studies, and we have also done triangulation. We also compared with time trend studies, so simulations that looked into the association over time, whether there's an increase you would expect if there's a strong risk from mobile phone use, given that a lot of people started to use mobile phone. So basically there's not quite some evidence that there's no association with brain cancer in adults or children. In terms of broadcasting, there's low certainty evidence for brain cancer and moderate, that's not written here, moderate certainty evidence for childhood leukemia. And for occupational, there's also low certainty evidence, also because there's more bias in this type of studies, which are often based on routine data and not fully designed. For other cancers like leukemia, thyroid cancer, non-Hodgkin lymphoma, there's also no indication, but you also see there's not that many studies available. So there's more uncertainty in that sense that the findings are not so robust. And the same for occupational exposure. There's not so many studies. Most of them are based on mortality data, cancer mortality, which is a limitation in particular for tumors which are not very fatal. So that makes also the evidence less certain. So basically, for other cancer, there's low certainty evidence that mobile phone use is not associated with leukemia, non-Hodgkin, and lymphoma or thyroid cancer. For base station, there was only one very small study, so there's really nothing to say here. And for occupational exposure, there's also low certainty evidence that it's related to any kind of, that it's not related to any kind of blood cancer or mouth cancer. Okay, so basically, I think what is interesting is really the amount of research which was available, so that really helped. There were 26 articles and 143 different exposure outcomes, like cordless phone versus some type of tumor, mobile phone versus some type of tumor, and there's no indications for an associations. As a last slide, I tried to summarize all the reviews that have been done. You see, I talked on the left corner on tumors and non-specific symptoms. You see there's mainly blue. Blue means that there's indications for absence of an association with high, moderate, or very low certainty of evidence. The darker, the higher the evidence. So you see what I talked about is mainly quite some evidence that there's no associations. There are, for other human studies, also mostly no indications for associations. There's a very few outcomes, but there's low certainty evidence. It's interesting, if you look at the animal studies, there's a little bit more going on in the sense that there's evidence for an association. But there's probably more to say here in terms of, obviously they have higher exposure and other settings. In general, I think the two review on acute effects on symptoms and tumors, it's really relatively, I mean, certainty is never there when you talk about science, but the evidence for absence of association is relatively robust. We have a lot of studies. For acute effects, we have good designs. So I don't think there will be a lot of surprises here. The only thing that can still be done is better exposure assessment, prospective studies where you continuously monitor the exposure. I think one problem is really that usage per se is not a very good proxy. You really should know how much your phone is transmitting, what is the output power. And that is one topic, and I would like to advertise that in our ETA project, where we have this app that on the one hand is used to generate maps. So here you see the situation of Brussels. Luckily, already a few people walked around with the app. So in Utrecht, where we have consortium partners, there's a little bit more data already collected. So on the one hand, this app really allows, and it works only on Android, unfortunately. It allows you to really contribute to mapping of exposure in Europe. It also gives you an indication how well is your signal and what is the output power if you use your phone. So maybe in this context, you may even use it as a kind of seeing how well is your networking working. So you see basically the quality of your network directly. And then you also give it gives an indication how much your phone will transmit if you use it in this situation. So thanks a lot, and happy to answer probably later questions.
Thank you very much for this interesting talk. Many thanks. And now I will go further to our next presenter. I would like now invite Josue Beck to give his presentation. He will join us online, and I see it works. I'm very happy that the technique is okay. He is senior researcher on the University of Medical Centers Amsterdam, Public and Occupational Health Department, and he is the methodologist for the WHO RF EMF Health Risk Assessment. And don't lose much time, so I will hand over to you for your presentation.
Thank you very much for inviting me to give this presentation about an important piece of work that Martin already has quite extensively explained. It's the WHO RF EMF project, who has the excellent lead of Emily van Deventer, and I'm the guideline methodologist. So I've been present through the project for some time now, but not from the very start. As Martin already said, project has a very, very long history. One reason that it has such a long history is that WHO changed its development of guidelines. It required in 2014 that every guideline is based on systematic reviews. So within the project, the strategy had to be changed. And we had to develop a set of systematic reviews that would underpin the most important health outcomes. And as you also heard from Martin, for most of these systematic review teams, doing the systematic review was much more work than they actually had anticipated. So I'm very, very happy that this part of the project has been finished and that now all systematic reviews have been published in Environment International. This is an overview of the reviews. We had 2 reviews on human observational study and cancer. Martin explained already the results of these reviews. Then there was a review on cancer in experimental animals. There was a review there were 2 reviews, one on male and one on female adverse reproductive outcomes, and 2 reviews on the same topic, but then in experimental animals. Cognitive impairment, 2 separate reviews, one on human observational studies, one on human experimental studies, and then Martin explained the reviews on symptoms, one the observational and the other one again in human experimental studies. And then we had an additional review on oxidative stress. We had planned a review on the effects of heat and pain and burns and cataract, etc. But unfortunately, that review didn't get through. We tried to get the protocol published, but there was a lot of criticism from the reviewers on the protocol, and then the project was so much delayed that we finally decided to cancel this, which I regret very much, because it is an interesting topic and not very easy, and it actually underpins the current guidelines. All the results of the systematic reviews are published in Environment International, and there's a sort of overview and introductory article that has just been published in September 2025. And through this link, you get to these articles, and they're all available free of charge. Well, the organizer asked me to specifically have a talk about the results of the systematic reviews. What do these results now actually mean? You can find the results in the systematic reviews. In each systematic review, there's a so-called summary of findings table. And that presents all the outcomes that are relevant and evaluated in that review on that topic. And for each of these outcomes, this summary of findings table provides a numerical result. For example, the risk ratio that Martin alluded to in the previous systematic review presentation. Numerical result, this is what we think the effect is. And then there is a 95% confidence interval that indicates a range of likely values that this numerical result could have also had. And in addition to these two numbers, there's also a qualitative assessment of the certainty attached to each result. And I'll go more into detail about what these things now actually mean. Just an example, Martin already presented it. The relative risk of glioma associated with mobile phone exposure compared to no exposure is 1.01, 1% increase in the incidence of glioma in the exposed group compared to the non-exposed group. And that numerical result has a 95% confidence interval ranging from 0.9 to 1.14, and that this whole thing is assessed with moderate certainty. So we're actually quite certain that these numbers are the true result. And I'll go into more detail about each of these different items. So first there is the effect, the relative risk. What do we think that the final effect of RF EMF on this health outcome is? The effect has a direction and has a magnitude. Usually for relative risks that are bigger than 1, this suggests a harmful effect. So 1.01 suggests that it might be a 1% increase in sense of a harmful effect on glioma from RF EMF. If the relative risk is smaller than 1, that suggests a beneficial effect because the incidence in the exposed group will be lower than in the compared group. And if the relative risk is exactly 1, that would indicate there is no effect. But, Martin said it also, there's always statistical uncertainty, and there is also a matter of confidence. So the 95% confidence interval reflects the range of values that are plausible giving statistical uncertainty. And if the 95% confidence interval includes 1, then the relative risk is not statistically significantly different from 1. That's similar to P is smaller than 0.5 that you'll all be familiar with. And then the third item, the certainty evidence, indicates how confident they are that the results that are in the numerical values really reflected the true effects. Again, I'll go into more detail how to judge a relative risk. So the glioma relative risk 1.01 means 1% increase in risk. Yeah, is that? Apart from the uncertainty, would a 1% increase in risk, would that be something serious, something trivial, or something that we can totally neglect? And then it's important to look at two different perspectives. The first is the individual perspective. What would it mean for me if the risk of glioma for me would be 1% higher than for non-exposed people? Well, that's easy. Everybody would increase that risk as negligible. This small risk, 1% increase of risk, would disappear against many other risks that we are exposed to. Usually a 30% increase risk, absolute increase of risk, is something that individuals perceive as something important. But then there is the population perspective, which is a difficult concept, but it means how many people would be affected if the risk in the population would rise with 1%. And then, because everybody is exposed, it means that even small risks can affect many people. The cumulative impact of all these small risks in individuals can still lead to a significant number of people being affected by glioma. Let's look at air pollution as a comparison, because air pollution is something that we're all very familiar with. and the outcome in air pollution is usually mortality. The relative risk for mortality with a 10 micrograms increase in PM2.5 is 1.08. So an 8% increase in a risk of mortality with every increase in 10 micrograms of PM2.5. And 10 micrograms PM2.5 is a, let's say, substantial level of pollution. But still, this relative risk is quite small, as you can see. But because many people, because we're all exposed to air pollution, and mortality is something that occurs quite frequently, this leads to a high global burden of disease of 7 to 8 million premature deaths per year. This is just to illustrate that even small relative risks can lead to a substantial number of people being affected. And the prerequisite for this to happen is that many people are exposed and that the baseline rate is quite high. How do we judge the 95% confidence interval? Well, it's an interval that has a range, and the wider the range of the confidence interval is, this would indicate a greater statistical uncertainty. And then it's important to note that the confidence interval is largely determined by the number of events and the size of the study population. So a very small study with, let's say, 10 people exposed to RF EMF and 10 control participants, and then we look for the risk of cancer, would come up with a relative risk of 5. So you would say there's a substantial risk. But as you can see from this confidence interval here in this slide, the confidence interval would range from 0.1 to 105. So from virtually no risk to the enormous increase in risk. And we would call this is statistically non-significant risk increase. There is, statistically spoken, we can be sure that this is 5 or almost 0 or a very high 105. And this is due to chance, of course. This is statistical uncertainty. And in a very large study, for example, with 10,000 exposed people, we would find a relative risk of 1.2, and then the confidence interval would range from 0.9 to 1.4, and we would still call it statistically non-significant, but we would be much more sure that the real effect is very close to 1. So if you want to have a narrow 95% confidence interval, we need more events, we need larger study populations, and we need more studies if it's in a systematic review. How do we now judge the 95% confidence interval of glioma? It ranged from 0.9 to 1.14. And it would mean that if this study or if the systematic review would be repeated many times, the effect would very likely fall within this range. However, if we try to make a judgment, does this now mean that it can be still harmful or can even be beneficial, then this confidence interval includes possibilities of meaningful benefit or of meaningful harm. And this is not really relevant from the individual perspective, but from the population health perspective, this could still mean a substantial number of people affected. For example, the comparison air pollution, 0.8 is the increase, ranging from 0.6 to 0.9, based on based on almost 10 million participants across 17 cohort studies, and that looks a bit similar as to what we have here, except that here the confidence interval crosses 1, so we are not sure that the risk is really above 1. How do we judge the certainty of the evidence? Martin already said we start with a high certainty of evidence. We assume that result that we have found is the true result, but when there is risk of bias, limitations in studies, if the results vary across studies, or if the evidence does not directly apply to the research question, if you have very wide confidence intervals or limited data, or if we know that publications of positive results have been published more, then we downgrade the certainty of the evidence. We say, well, there's some problem here, and that makes us less certain that this is the true result. For glioma, the certainty level was moderate, and that's mostly due to the fact that we have observational studies, and there we can never be really certain of the result. And there was no downgrading applied. The level of certainty started and remained at moderate. So do we now know that there's really no effect? Martin used different types of stating this result. Sometimes he said there's no association. Sometimes he said it wasn't statistically significant. How could you actually say that there's really no effect? Well, you would like to see that the relative risk is 1. But there's always statistical uncertainty reflected in the confidence interval. So you would like to see a confidence interval that would be outside, or that where the confidence interval limits lay outside a specific pre-specified threshold that defines what counts as no effect. And you can see it in the figure here. So this would be a trivial or no effect, because there is a threshold for a benefit on this side and there is a threshold for harm on that side, and the confidence interval completely covers everything that is between these two sides. But we don't have that for our RF EMF. So that is a real problem. Even though I tried during the whole project to get this discussion going, no one actually wanted to engage in it. So I looked at other WHO guidelines. What do we have there? And there's, for example, a comparable WHO drinking water quality guideline. And in that guideline, they do define what they call a tolerable risk. For example, for cancer, chemical exposure in drinking water would not be allowed to cause more than 1 in a million lifetime cancer risks. This 1 in a million lifetime cancer risk is one of the very few criteria where we think that risks that are smaller than this are, nicely said here, tolerable or acceptable, or things that we would be able to accept. So how would that apply to, for example, the no effect for glioma? It suggests that there is no statistically significant effect. That's, of course, very important, because it means that it can easily be 1, and the confidence interval still includes potential harm or benefit. What would be a reasonable no effect threshold or tolerable risk? We could take the water quality guidelines and take a tolerable risk of less than 1 in a million lifetime cancer risk. And I can tell you that when you make the necessary calculations to find out, then if you want to be sure that the confidence interval doesn't include this risk, then the confidence interval has to be 1,000 times smaller. We could take the air quality guidelines as a sort of thing of reference, what we think is a risk in air quality, as this 1.08 for mortality, or in that guideline it's also looked at the lung cancer risk, that's 1.12, and then you see that these risks still are in the glioma level, the range of possible outcomes. So actually, I would say we're not totally certain that there is no effect for glioma. There is no statistically significant effect. It's quite clear that it could be 1, but there is a number of ranges, a number of results that would still be probably not accepted in other fields where we have guidelines. How could we get a narrower 95% confidence interval? Well, more studies, for example. We could also have more discussion needed to define what is a tolerable risk threshold. Anyway, the current evidence says there is no statistically significant effect observed, but we can discuss and think a little bit more on how to further elaborate it. So if we now look at all the results for cancer that Martin also presented, then here you see an overview of the systematic review results for every outcome in the systematic reviews. So this is the 95% confidence interval, and here is the effect, the no effect line, the relative risk of 1. And you see for all cancer outcomes in the systematic review, results are statistically non-significant. But when there are more data sets, more cases, more studies included, you see that the confidence interval is much narrower. For example, this is the result for mobile phone exposure, very narrow confidence interval. The result for, the other phone results, there's only 3 studies, only 1,000 cases, and a much wider confidence interval. Almost like the confidence interval is equal to the number of studies or the number of cases included. Anyway, we can say here none of these results was statistically significant. If there is still something that could possibly be relevant, is a matter of further discussion. And of course, this is only the result of the human observational studies. In the end, you would combine that with other evidence, animal studies, other evidence, mechanistic evidence, and especially in the mechanistic evidence, I think there's actually not anything there that points to a specific mechanism, which would then also reinforce the possibly no effect results of glioma. Yeah, then there is the systematic review on cancer in animals, and that's actually a little bit a different beast than all the other reviews that we had. The important methodological difference is that they didn't conduct, the authors of the review didn't conduct a meta-analysis, and they didn't provide a numerical summary of the results. They didn't calculate, even though that would be possible, they didn't calculate a relative risk because they said that would be misleading, because then it would look like that the relative risk would be similar in animals as in humans, and that's not the case. Their definition of an effect was therefore different. They said, if there is a statistically significant increase in cancer incidence due to exposure in at least one study, we conclude that there is an effect. That for this cancer outcome, RF EMF causes cancer. But the studies showing no effect are not considered in this conclusion. Only studies that provided a statistically significant increase. The certainty of the evidence is based solely on the positive studies. And then the evidence is rated as high certainty if the study is large and has a low risk of bias. So my key concern with this is that different methodological approaches can lead to different conclusions. Because if you analyze these data in a different way, you get a different outcome and you get a different certainty of the evidence. And unfortunately, the authors didn't want to address this in the review. Okay, I think that is something to think about and to discuss, and I'm quite sure that there will be more discussion on how to assess the evidence in reviews of chronic bioassays or cancer in animals. Then a short note on RF EMF and cognition. This is again a similar plot as I showed you for cancer. This is the line of no effect. Then these are the results of one outcome in this review with the specific effect and the confidence interval. As you see here, all the results cross the line of no effect. So also in this review, there is actually no statistical significant result. And as you see here in the certainty of the evidence assessment, many of these results are assessed as high certainty evidence. Now, what does this now mean? How to judge these results is difficult because there's many different tests used. That causes a challenge for the interpretation. Again, I would look at the individual perspective and I would look at the population perspective. For the individual perspective, we have a sort of standard here that if the score is if the score of a patient on a specific test is 1 to 2 standard deviations below average, then people start to wonder, there might be a problem with this patient. The review findings show very small effects, fractions of a standard deviations, with quite narrow 95% confidence interval. So for the individual perspective, I would say nothing to be worried about. From the population perspective, I don't know. It's complicated. If the reaction time in the population would decrease with a little fraction, would that be dangerous? I don't know. I have no idea. And it's a difficult discussion, and I haven't been able to convey that concept very well. And I think there would be more study needed to be sure what the population perspective here would be. Anyway, the certainty of the evidence is rated as high, and the results are likely to reflect a true effect despite being small. Then I would like to summarize the results for the other health outcomes very briefly, because they have been extensively described. For female fertility and for fertility in male persons and animals, the observational studies show actually no clear pattern, and most of the studies are of a very low certainty. And that is a pity, of course, because if the studies are very low certainty, then we are not very sure about the results of the studies and we can't say much about it. For animal studies, both in the female and in the male fertility range, there are consistently positive outcomes. But usually the certainty of these outcomes is low, but still I would say there is something there, especially at very high exposures. These are exposures that usually don't occur in daily life. But RF EMF, especially through the heating mechanism, might have an effect on fertility, would be my conclusion. And then for symptoms, Martin has extensively reported on it. They are quite consistently negative, and there is moderate to low certainty evidence there. Oxidative stress, one of the possible mechanisms that would underpin, for example, an effect in cancer or an effect on cardiovascular results. These studies, is there an effect of RF EMF on oxidative stress? These results were so inconsistent that in spite of very precise PECOs, where there is the population would be very similar, the outcomes would be very similar. The results went all over the place, from very beneficial to very harmful, and we weren't able to conclude anything. So I would say there's certainly no evidence that there is a mechanism in oxidative stress. So that brings me to my final slide. You asked for a Christmas present. I'm afraid it will not be there. The task group has the task to integrate the different results of different evidence streams into a conclusion on a broader health topic. For example, integrate the observational cancer review and the animal cancer review into one conclusion about cancer. That discussion has still to be held. It has already formulated for all other topics conclusions, and we hope that the report will be ready by the end of the year. But then there is an external review group that will review and comment the task group's report. And then there's another hurdle of the WHO guideline review committee that will evaluate the report according to the WHO guideline handbook. And only after this process being completed, the final report will be published. And I'm afraid that's going to be in 2026, but it's quite close. Thank you very much.
So thank you very much for the very informative presentation. And now I would like to invite you all for the Q&A session. There are microphones in the room, I think. There are microphones in the room. If you have a question, please raise your hand. And before asking your question, could you please briefly state your name and your professional background, and who should answer this question. And I think Jack will check the online questions, and I see the first question in the room, and I will invite Martin to come to the stage for the answers of the questions. Yeah, please.
Hi, Murray Romney, independent consultant. A couple of questions. One is on the studies on the perception of EMF, this IEI stuff. I can see statistically there's no evidence for it. Has there ever been any example of an individual who has actually managed to beat the odds in a way that is actually definitive? Very specific question, because I get this all the time. People tell me I can detect Wi-Fi, and I say, well, here's £5,000, prove it. And they never get back to me. So that's the first question. The second one was to do with the WHO study. I noticed that the comments on fertility, oxidative stress, and are basically discounted. When that WHO report is written, can there be a large amount of explanation for why that conclusion came? Because those are the two things I think that most of the people concerned about EMFs have. And I have seen what looks like good evidence for it, but I've not gone into the detail. But if it's just discounted, then the whole report will be discounted. But if it's discounted in a way which is very specific as to why it was discounted, I think that will make a big difference to the credibility of the report. Thank you.
Okay. Yeah, it's a very, very good question about this type of perception, because, of course, there's the theory or hypothesis that maybe in this big group of IEI there might be hidden a few individuals that indeed can perceive this exposure. And there were a few studies that tried to do this individual testing. For instance, one study which was very interesting is done in the Netherlands, where they went to the home of the people, because some people also say, if I have to travel through the city and come into your lab, I'm already finished emotionally. I cannot react anymore. So they really went to the home, and then together with the participants, they tried to figure out which signal makes you problem. So some people said it's Wi-Fi. So to really also address this criticism that maybe people are very sensitive to very specific signals, as some of them reporting. And then in an open test and trial process with these people, they have then tried to see, okay, that's exactly the level where I can feel it, but still don't have adverse reaction. And once they have set the level and the signal and everything, they have done a double-blind testing with 10 attempts per person. And the idea is if somebody can do more than 8 hits in this 10, which corresponds to a 5% likelihood, they would redo the testing and see whether they really can perceive. They have included 80 people in that study, and 2 could have 8 hits, but both of them didn't want to do a second testing. So 2 out of 40 is exactly what you would also expect by chance. So basically there are a few other of these studies. There's not that many of these studies. Most looked only at group differences. But to answer your questions, none of these studies could identify any individuals that could react to that. And that's a problem of science. You can never prove that something does not exist. So of course, unless you have tested everyone in the world, you cannot be 100% sure. But at least you can definitively conclude that the likelihood to find this is very, very low, if it is at all. And of course, it would be very interesting. And I'm actually convinced that if there are such people, and they could convincingly do that in self-testing, they would have approached me. I've approached by a few individuals. I did some kind of this testing. It never worked out. So I think there's also a kind of bias here in the sense, if somebody really can do that, then they would do it. Also in the studies that I've presented, a lot of studies looked into that and asked people, but they didn't report the results, so we could not include. There was just one notion in the studies. Nobody could perceive the fields or things like that. So I'm quite convinced that in principle, if there would be a reasonable proportion of people, let's say 1 in 1,000 or so, it would have been detected in studies so far.
Okay, and I think the second question to Verbeek, it was about the reaction of official reaction to the reviews.
Yeah, well, actually, if I understand the question correctly, he is asking if we are going to downplay the results, downplay the results in the fertility reviews or oxidative stress. Well, there has been no formal judgment of these results yet. The task group is still doing it. And the process is that we both assess first the hazard. For example, can RF EMF be a hazard for fertility problems? And then we look if there is a risk at various levels of exposure and what that risk is. And the people in the review, I think, did a good job in stating that possibly at high exposure levels, there are real risks for fertility, both in male and female fertility. How the task group will translate this in a final conclusion on the hazard, is RF EMF capable of influencing fertility? And how the task group will finally translate this into a risk, possible risk at, let's say low, moderate, and high exposure levels. Yeah, that's still unclear. So you have to wait until 2026, and that will be done. That is an independent process by a number of independent experts that are in the task group. So let's assume that they will do it in a fairly transparent and clear way.
Thank you. Now I have a look to check. Do we have some online questions? We don't have, so I will add a question for my own to Verbeek. You have been involved in systematic reviews to other agents. How would you compare the research situation for RF EMF to other agents?
I did already my best to, for example, compare the results to the air quality guidelines. And for example, if we compare the mortality due to air quality to glioma and RF EMF, then you find a comparable number of studies, comparable quality of studies, and outcomes that differ slightly. So I would say in terms of the number of studies and the quality of the evidence, these guidelines are comparable. However, it is much more difficult to say that there is no risk or that the risk is lower than a certain threshold than showing that there is a statistically significant risk, because everybody takes that for granted. So the result in the air quality guidelines of the relative risk of 1.05, that this is a risk, is just based on statistical significance. So far, the result that there is no risk for glioma due to RF EMF is only based on the fact that it's statistically non-significant. So it's very comparable, and I think in both guidelines, a real threshold of what be a threshold of serious problems is missing.
Mm-hmm. Maybe an additional question to both, I think, after the systematic reviews, where do you see areas where we let's say it directly, we don't need more research, and where are the areas where we have to do more research? Maybe, Rebecca, you will start to answer.
Yeah, this will be one of the questions that will be answered by the task group. So this is just my very, very personal opinion that I'm going to give you. And I think without certainty about a specific mechanism, other than thermal effects, you can look endlessly to find something, because it's really a fishing expedition. Is there an effect of RF EMF on whatever health outcome is possible without a specific mechanism? So I was very happy that we decided to concentrate on 6 important health outcomes. So there's already a restriction to evidence where we think it's important. Within these 6 topics, we have an enormous amount of evidence. There's hundreds and hundreds of studies. So it is very unlikely that additional studies without a very serious improvement of the methodological quality will add anything to this evidence base. And I think, for example, for the human experimental studies, there's enough evidence. There's high certainty that there's no effect. No need to do more studies. The human observational studies could probably be improved by better exposure measurement methods. That in the future you could easily imagine that there would be a personal exposure measurement that would be far better than just mobile phone exposure, in terms of how long do you use mobile phones, or how long do you use mobile phones. So only if there is a real improvement of the quality of the studies, there could be a change in the evidence base. But otherwise, more of the same studies, no need to.
Maybe you can add, especially on symptoms. Are we finished, or do we need further research in symptoms?
Yeah, I agree with yours that for acute effects of symptoms, I think this is pretty well solved with randomized, well-done studies. It's a bit more tricky with long-term effects. I think it's really tricky to say if there's no clear mechanism, what should be done. But on the other hand, and the history has shown for many other exposures, often mechanisms are more targeted, investigated if you have a macroscopic association seen. So like first they have seen smokers have lung cancer, and then you start to understand the mechanism. The same happened in air pollution. It started with the association. And given the potential high impact of these exposure situations, I think it's justified to look a bit deeper still into this, because otherwise it also creates a vacuum. I see really issues. One inherent problem is that we have guidelines, let's say for far field exposure, for environmental exposure, which are much higher than what actually happens in the population. So basically we really don't know a lot what happens if people are exposed several weeks for 40, 50 volts per meters. So I think there one could think a bit more. And then obviously for all observational research, we really need better exposure assessment. And in principle, it's very easy. We have a mobile phone that could collect a lot of information that could be prospectively used for exposure assessment. In practice, we learned it's very difficult. But in principle, I think they're there, and maybe that's really also a call for the manufacturers. I mean, to have a joint collaboration, how we can implement tools in the mobile phones for prospective studies, like in Cosmos or so. I think we could do a lot. I mean, we have so many studies on brain tumors, just because we have brain registry and so on. We have almost nothing for neurodegenerative disease, because it's so difficult to do. You cannot do retrospective studies. So I still see many gaps. Of course, it's a judgment when you don't have a strong a priori mechanism, but still I think it's worth to keep on going. But I feel really we need to profit from the technology. Otherwise, this type of how much did you use your mobile phone the last 20 years? We don't know when it transmitted. We have this different use. I think this will not lead anywhere, and that's really also something we try to improve with Goliath and all these studies.
So thank you very much to Martin and Jos, and thank you all for participating this part of the EMF Forum, and we'll hand over to Jack for, I think, the next very important part of this conference.
Yes, and I'd just like to echo Manfred's thanks to Jos and Martin for those very informative presentations, and now I need to think about something else to ask for Christmas, clearly. We're going to continue scientific themes in the next session and hear an update on the European Commission-funded Goliath project, and also a discussion about how expert groups conduct the risk assessment and monitoring of the ongoing science. And I will turn it over to Stefano Delia from Vodafone Group, and also a member of the GSMA EMF and Health Group, to run the session.
Thank you very much, Jack. Exactly as was stated by Manfred, I will not take a lot of time. I'm here just to facilitate, representing the industry. For us, it's very important to listen to scientists, to learn from scientists. And today I'm honored to facilitate this session where we have 4 important scientists that will speak, and we will learn from them about some very important topics. The first one is the Goliath project. That is probably one of the most important research projects ongoing, founded by the European Union. And we have the pleasure to have today with us, please, Dr. Gemma Castagno, that is the scientific coordinator of the Goliath project, and also connected remotely, Monica Guxens, who is the coordinator of the Goliath project. They are both from the Barcelona Institute for Global Health. So I will not take additional time. I invite our speakers remotely and who are with us, let's say, in this room to join. I kindly ask you to hold your question until the end of the presentation. After the presentation from Monica and Gemma, we will have a panel, and I will invite 2 additional distinguished speakers to join the panel and to have an overall discussion on Goliath and on the advisory group of experts. Thank you very much. Thank you, Gemma.
Thank you very much for the invitation to present the Goliath project. As Stefano was saying, Goliath is one of the 4 projects that have been that were funded by the EU in the last call. And I will try to give you a brief overview of what we do in Goliath. So that's the Goliath project that's entitled 5G Exposure, Causal Effects and Risk Perception through Citizen Engagement. And I have already been presented. I'm the scientific coordinator of the project. And online we have Monica Guxens, who is the principal investigator. So just a very brief overview of who are Goliath. I'm representing Goliath, but we have quite a lot of researchers in the project. So we have 25 partners right now, most of them in Europe, but as you can see here, we also have some partners in the US, and some other partners join later from Asia, and mainly it's Korea and Japan. The project will last 5 years, and well, the EU contribution is around 7 million euros, but some of the partners have their own funding, so it adds up to a total of more than 10 million euros, which is quite a big project. Okay, so let me explain a little bit what are our goals. So we want to characterize and monitor the RF EMF exposure, in particular 5G. Nowadays, that most of the countries are deploying all the 5G networks. Also want to provide novel insights into the potential causal neuropsychological and biological effects, if there are any. A big part of it that sometimes it has been not studied in much detail in the previous projects is a little bit to understand how people perceive the risk of RF EMF and how we, as scientists and experts, can communicate all the possible risks, if any. And we want to do this with engaging also the citizens. And finally, all this will use an integrative and transdisciplinary pan-European approach. And here you can see the PER diagram, where you can see more in detail the different work packages. You probably, most of you know, the European projects are organized in work packages. So in the columns, we have the column about exposure, and then there's a column on the right about the effects. And then we have 2 rows on the top part. So in the first, we want to first characterize the exposure of RF EMF in young people and also in workers. And for the health effect part, we want to assess if there are any neuropsychological effects of this RF EMF exposure. In the lower part, so for the experimental part, there's also a part on exposure where we want to assess the dosimetry and do all the exposure setups. And for the experimental part, the effects that we want to study are brain function mainly, and also thermoregulation and radical stress. All this information that comes from this research will fit into kind of another block, which is about more exposure prevention solutions. Here we have different work packages related to this block. So we want to understand what are the health impacts of the RF-EMF exposure, and how, as I was saying before, how people perceive these risks, and if there's any exposure reduction scenarios that we have to take into account. We want citizens to be involved in our research because we want to understand from them how they perceive the risk, and they help us create tools to better communicate this. And also, well, we'll do also the communication, dissemination, and policy brief that are needed to make our results visible. All this, of course, goes into the big framework that it's on the far right, with taking into account all the ethical, legal, and societal issues. And as you can imagine, a big project like that, and with so many researchers involved, so we need quite a lot of coordination and management. So I will briefly describe a little bit more about the different work packages. So work package 1, about RF EMF exposure. So we want to understand and monitor what's the use of the communication devices nowadays. Because we know that even every day more and more we use more communication devices. We have this widespread use of Internet of Things. We are connected always. So we have to understand how we are connected and monitor all this exposure. For here, again, if you remember from the PER, we have 2 sides, the young people and workers. For young people, we did a questionnaire. It was kind of a panel survey, 4,000 young people around Europe. And we asked them which devices they use. And we asked them also, for each of the devices, what activities they do. So for which activities they use a device. If, for example, they connect to social media, they use for work, they use for studying, they use for calling, for texting, streaming, etc. So we have all this information already collected, and also it's important to know the position that they use. So it's not the same when we have to calculate doses to use your phone next to your ear, or use your laptop in front of you, or on your lap. So all this information we're trying to collect. For the workers, our aim was to identify the new and emerging occupational RF EMF sources and scenarios, monitor the current evolving exposures related to these sources, and we will like to have and to do some personal measurements and spectral spot measurements in the workers and compare these exposure levels in occupational settings with non-occupational settings. Also, in the work package 1, we want to characterize the RF EMF exposure patterns. And here you can see this graph that depicts a little bit what we want to do. So we will do some spatial and temporal monitoring with some activity-based microsurveys, and I will explain about them later. We'll do some spectral spot measurements, uplink measurements, and temporal multiband nodes and prototype nodes that we will using. All this will fit into the stochastic and machine learning modeling to calculate in-body absorptions, and from then we want to derive two models, two RF EMF, those models, one for experts and one for public. In work package 2, so this is the work package about trying to see if there are any effects of the exposure to RF EMF. And here it's important to mention that we want to use kind of a state-of-the-art causal inference method. So we try to overcome some of the limitations that we have faced so far in the previous studies. How are we going to do that? Well, we have 8 cohorts, again, both in Europe and Asia, and we have around 4,000 participants. So that's quite a lot. And we have longitudinal data. It means we will have repeated measures for all the cohorts. And part of this kind of a state-of-the-art method will include approaches to control for unknown or unmeasured confounding, approaches that balance the background covariates, and do some sort of triangulation of results to try to, as I said, to overcome some of the limitations that the studies published so far have. For the workers, the initial design was to do a controlled crossover quasi-experimental study, meaning trying to find some companies that did not have any 5G installed, do pre-installation measurement, and then do a post-installation measurement and some health effects measurements. But this has been proven quite difficult. It's not easy to find these companies, so probably we're now moving to doing just a cross-sectional design, and we'll do a pre-post shift measurements, but that's what we can achieve if nothing changes. There's the part on the experiment where we have the doses and all the dosimetry calculated, and then we have all the experiments. In the experiments, we will have the different type of experiments. We'll have in vitro, in vivo, human, and in silico experiments, which is quite a big range. And we will estimate 3 different outcomes. As I mentioned previously, we will estimate brain function, thermoregulation, and radical stress. We will not do all the outcomes with all the experiments, as you can see in the table, but we will have, for each outcome, we will have several experiments, and we are experimenting with different frequencies and different SARs. And if you are just keep multiplying each outcome with each type of experiment and different frequencies and SAR, this adds to quite a lot of experiments. In work package 6, so I have explained the first part of the PER diagram, then work package 6. So we think that understanding the mental models of RF EMF exposure is key, and it's key to communicate risk to the people. So far, we have a lack of clarity around the nature, magnitude, and likelihood of potential health risks, and this can lead to misapprehension, concerns that are not real, etc. So the mental models that we will develop in Goliath want to address this poor communication of the potential risk associated with exposure to RF EMF. With these mental models, what we want to do, we want to identify misconceptions by comparing, how experts, people that know about technologies, health, etc., and non-experts, so public, perceive and think about the exposure. And to do that, this will be done with some qualitative interviews that I will also explain later, but also we did a survey, a European survey, including 10 countries, to try to understand a little bit these kind of misconceptions. Also, in this work package 6, we will evaluate these exposure reduction X scenarios to try to help people to better understand and accept the RF EMF technologies. So we will select exposure reduction scenarios that are likely to have a large impact on exposure, as well as scenarios which seem counterintuitive to lay people. So because we have the experts and then lay people that might have very different views on that. We will do both in young people and in occupational settings. And our aim is to have a web-based interactive public EMF dose model to allow the public to quantify somehow their dose with some of the data that they'll have to input to, at the end, have a better acceptance of the communication infrastructure by the public. Okay, in work package 7, it's this work package about kind of more co-design, more having citizen engagement. We will try to engage people, so young people and workers, to address these kind of doubts, these concerns that they have about the RF EMF exposure. It's important here to try as much as we can to engage people, even if it's not easy, let's say. We'll try we have already done some workshops with people, including here both expert and non-experts, but yeah, we are working on that, but the aim is to finally get to a point where we co-design and test some communication formats and messages to properly address these kind of doubts or misconceptions, concerns that lay people may have about RF EMF exposures. Work package 9, it's, again, I want to engage in a dialogue with stakeholders because we are not alone in this world. So as you have seen so far, we are taking into account experts, we're taking into account citizens, but also there are other stakeholders that need to be taken into account, and we want to have a broader view on that because people have different perception of the risk, and these perceptions are influenced by different factors, such as, the consent, the potential for some kind of discrimination, other societal factors that can influence. And we will take all this into account. This is just a brief overview. So, as I said, Goliath is one of the 4 projects funded by the EU in the last call, but there were 3 other projects also funded, and the 4 projects altogether, we have formed what is called the CLUH, which is the EMF and health cluster. The 3 other projects that are part of the CLUH are C-Wave, that's led by Theo Samaras from Thessaloniki in Greece. We have ETAIN, that's led by Anke Hoes in Utrecht, the Netherlands, and XGEM led by Nikos Petrolakis in Greece, and finally, Goliath, which principal investigator is Monica. And the aim of this CLUH, this cluster, is to develop some joint activities, so to put all the knowledge that we're generating together. And so far, what I've been doing, we have some working groups specific on scientific strategy, data management, communication policy. We have already published 1 policy brief, and we are almost ready to publish the second one. We have a joint web page, we have annual meetings, a newsletter, etc. And some other tools that we're developing, like a joint stakeholder list, that it's a live stakeholder list that we are feeding, and then we do some trainings and workshops. Okay, now I will explain a little bit more in detail what I've talked so far, the brief overview that I did, and I will start with these activity-based microenvironmental surveys. This is the aim to assess in detail the RF EMF exposure in multiple microenvironments, and then we're doing this in 10 countries in Europe. What we do? So the microenvironments are in different areas: outdoor public places and public transport. And there are our technicians walking around these different microenvironments with some devices to measure the exposure. And here it's a little bit more detailed, these microenvironments and the type of activities. So this is a person, one of our technicians, carrying the backpack with all the measurement devices inside. What do we have inside? We have the ExpoM, and we have an add-on device, and we have the QualiPOC software. In each of the microenvironments that we have set up before in the protocol, and kind of the same type of microenvironment for all the different countries, we do 3 scenarios, so measurements in 3 different scenarios. And the scenarios are the non-user, the maximum downlink, and the maximum uplink scenario. So here, just to recap, we have several microenvironments, like public places, outdoor places, and, well, you'll see later, and we have 3 different scenarios: the non-user, maximum downlink, and maximum uplink. And I will show you some of the data that have already been published about the monitoring of these microenvironmental surveys. Let's start with the data that comes from the ExpoM. Yeah. Okay. Here it's a broad, it's a graph about the mean, the power density that you can see on the y-axis, and then on the x-axis you can see the different countries where the measurements have been done. So here, down here, and then you have the 3 scenarios: the non-user, the maximum downlink, and the maximum uplink. And the little dots in each of the plots, in each of the bar plots, and in each of the box plots are the different microenvironments that you don't have to look, but just to explain you what you can see in this graph. So in general, what do we see? So we see that in the non-user scenario, the levels are much lower than in the other 2 scenarios, so that's clear. But even if we look a little bit in detail, in the non-user scenario, we can see that there are some differences by country. For example, we can see Switzerland have lower levels, and for example, the Netherlands have higher levels. So there's, in general, lower levels so lower power levels in the non-user scenarios, but differences seen in the different countries. When we go to the maximum downlink scenario, so the one that you can see in the middle, you can see that the levels are higher. Okay, again, with some differences between countries, and that need to be considered. And finally, the highest levels are seen for the 3rd scenario that we measure, which is the maximum uplink scenario. And here, once again, we can see some variability in the different countries. And we can see some of the countries like Poland or Spain, they have lower levels, and there are some countries like the Netherlands that have higher levels. But in general, non-user scenario is the one with the highest, with the lowest levels. Maximum uplink scenario is the one with the highest levels in power flux density. Now, instead of looking at the countries, we look at the type of city according to the degree of urbanization, and we categorize the different cities into large city, secondary city, or villages. Okay? Again, we have the three scenarios: non-user, maximum downlink, and maximum uplink scenarios. And here at the bottom, you can see the three different type of cities. So for the non-users, what we see is that in rural areas, the non-user scenario, so the environmental exposure, is lower in villages compared to large cities or secondary cities. So, and it's quite lower, even if here you don't see so much the difference. Take a look that this is a logarithmic scale, so yeah, the difference is quite high. If we move to the maximum downlink scenario, we can see that the levels are a little bit higher compared to the non-users, and they are more similar between the different type of cities. Let's move to the right of the graph in the maximum uplink scenario. Here, what we can see is there's a trend of increasing the exposure for the villages. So in urban areas, there's less exposure than in villages, and probably this is due to the lower density of base stations. So in villages, there are not many base stations compared to, for example, large cities. So the exposure is higher because the device and they need to emit more power to get connected. Now we are trying, we see this graph. In this graph, we see similar of what I showed you before. Again, we are looking at the power density for the exposure, and here below we can see the different countries, and in the graph what we depict is the different bands, so we can see which bands contribute to the exposure. So for the non-user scenario, which is the one on the left that you can see on the graph, mainly it's the mobile DL bands that are contributing, and even that the levels are quite low, we can see that there are, again, some differences between countries. If we move to the maximum downlink scenario, what we can see is that here levels are higher than the non-user, as expected, and here the ones that depicted in purple, violet, and this is the contribution of the 5G bands, the mobile TDD. And again, some of the countries, as you can see, they have higher levels. For example, it's quite notable the higher levels that they have in the Netherlands, and they don't have any 5G. They have not started deploying the 5G. Moving to the right, now we have the maximum uplink scenario, where here you can see that the levels increase, again, quite a lot. And you can see the contribution of the different bands for the uplink. And yeah, you can observe that some of the countries here, the countries in the middle that are Hungary, Italy, Netherlands, and Poland, they don't have a contribution from 5G in this scenario. Here to take into account that also the differences that we see in some of the countries may be due also to the regulations or the precautionary principles that are in each of the countries that we have measured. So, about precautionary principle, does it help? Do we have? So, is it good to have this precautionary principle? It's not. Does it do more harm than good? So here are different opinions. So we can have the opinion, okay, precautionary principle might trigger concern. So as it's popularly said, where's the smoke, there's fire. So it means if we put a precautionary principle, it's because we think there's some risk behind it. Okay, so that's one of the options. And on the other side, what we can say, well, the precautionary approach, what may happen may increase the trust and accountability of the government. So the government wants to be safe, so people can think, okay, the government wants me as a lay citizen to be safe, so they put this precautionary principle even if they know that so far there are no health effects. So that's kind of somehow kind of a tricky situation. And here we have depicted in yellow in the graph the countries that have applied this precautionary principle. And for example, for the non-user scenario, you can see the ones that have the precautionary principle, like Belgium, Italy, and Switzerland, the environmental levels are quite low. But if we go to the maximum uplink scenario, the situation is not the same, because some of these countries that have this precautionary principle in place, they have quite high levels, such as Italy. So this data is the one that we obtained with exposure measured through the ExpoM. So now I will show you some of the data that we obtained through the QualiPOC software. And this data is only related to the maximum uplink scenario. So here, we can see, again, on the graph, on the y-axis, the power, and on the x-axis, the different countries where it was measured. We could not measure in all the countries, in the 10 countries that we did the survey. And here what we can see, for example, is that there's a high average transmit power in the Netherlands, as we saw before, which is the second bar that you can see in the graph, and there are some others that are lower. For example, in the UK, but in the UK it's a special situation, because here we did not take into account the 4G is missing, so this should be taken in caution, because it's not really all the data. So, but yeah, the one that it's kind of the highest is the Netherlands, and also there are some Belgium, Hungary, and Italy that they have also quite high levels. Instead of looking at the countries like before, if we look at the degree of urbanization, let's say, if we compare big cities with that BC, this kind of light blue, with secondary cities with darker blue, and then villages with this purple, the trend is similar to what we've seen before. In general, we see that the uplink, when in the uplink scenario, what we see is the power is higher in villages compared to secondary cities or light cities. And finally, if we have a similar graph with the power, but then here the different bands that contribute, we can see that in general 4G have higher levels than the 5G. And the 5G, you can see, are the ones that here in that square. So on the third graph, the ones on the left are the 4G bands, and then the ones on the right are the 5G, and we can see that these levels are lower. Finally, for the add-on device, so this is the third measurement device that we used in our study. Here, again, you can see on the y-axis the power, on the x-axis the different countries where we did the measurements with this device, and the three different scenarios. The non-user in red, the maximum downlink in green, and the maximum uplink in blue. Similarly to what we've seen before with the other devices, the one with the scenario with the highest levels are the maximum uplink, the ones in blue, and we can see that the non-user or environmental levels have the lowest power when we compare the different scenarios. And again, here what we can see is there are differences between countries. So we can see that, for example, for the non-user. We see some countries that have higher levels and some countries that have lower levels, and the pattern is similar for the other scenarios. If we do the comparison between the degree of urbanization, and similarly, we see for the non-user environmental levels, we see that villages have lower environmental levels, and then when we move to the downlink or uplink scenarios, we can see that these levels are much higher in villages than in, for example, large cities. And probably, again, this is due to this lower density of base stations that need more power to transmit. Just to give you a brief overview, so far I've been talking about these kind of microenvironments, but just to give you a bit of more detail and refined data. When I was talking about microenvironments, outdoor places, public transport, etc., here's a graph where you can see the different places where we have done measurements. So we have classified not only the cities where we do the measurements in large, secondary, or villages, but also inside each of these type of cities, we tried to choose the different areas where we have done the measurements. And here you can see on the x-axis, you can see there are businesses areas, there are downtown areas, education, industrial areas, playgrounds, public transport, residential areas, shopping centers, stations, etc. And what we can see here, for example, if we look at the blue bars, which are the non-user scenario, we can see that, for example, in the business area, it might be quite busy with people, there's quite high levels of, let's say, environmental exposure, because, well, we have quite a lot of people, and this we don't see this in the other scenarios that we have measured. And another thing, for example, is for transport. Here you have public transport. And then for the public transport, some things would need to be taken into account. First of all, public transport. We are in a moving, whatever, train, bus, metro. So we have to change the cells from one bus station to the other, and also just we are inside a vehicle, which means that there is some blocking. It can happen some blocking from just the structure of the vehicle itself. So all this needs to be taken into account. But it was just to depict you a little bit what we have. And finally, this is just the illustration of the mental models that we have developed. So after the qualitative interviews that we have performed with experts and not experts, we have finally developed this kind of complex mental model to try to understand what are the benefits or risk, or how people perceive the benefits or risk of this 5G in our everyday life. So just very quickly, on the left side of on the left side you can see the exposure. Here you can see the perception of the risk or benefits, and then all the different factors that you can see. We'll not go into detail, but all the different factors that you can see in this graph are the different factors that somehow play, or they can make a difference in how we are exposed and how we perceive this exposure and everything. So as you can see, these mental models are quite complex, but I think this is the base to understand how we have to communicate risks. And well, I think that's pretty much what I wanted to tell you about Goliath. And I'm the one speaking here. Monica's online, but some of the people here in the room are also involved in Goliath, and they are big contributors to all this work. Thank you.
The next step is a panel where we will have a discussion regarding what we know and what is uncertainty on scientific research. But before we start the panel, if there is any question for Gemma specifically on the Goliath project.
I'm Leo Kammerman from Uruguay, from Antel. I was a little surprised with the grouping of people and young people and workers as a group of study. And I wanted to know why, and I wanted to know what workers are you going to study, having into account that occupational workers have in other studies shown that with a low exposure.
Okay, so for the first question about why young people and workers, well, it was part of the call that said that we had to look for, let's say, sensitive groups. So young people are developing, and also they are the ones that are more, I guess, that nowadays more heavy users of the new technologies. So they are a group that it might be more exposed. And workers, we have every day, and we know that every day, everywhere where we are, we're exposed to some RF EMF, but workers have it even more, and they can have it more directly. So it can be also a group that can have higher exposure, and that's why we chose these two groups of people. And then for the workers, it's a very good question. For the workers, we had some difficulties trying to recruit workers. We had to change a little bit the idea that we initially had. So what we're doing now is try to just get people that are exposed at work, but the levels, I mean, it's not that they are, so far we have, if I remember correctly, we have found a company that collaborated with us that are staff that are working in a football stadium in the UK, and also people working as the staff in a concert hall. So we try to recruit these people, even though that they are not really, that it's like general population, but during work we are trying to assess if there's kind of a high exposure during their work time, so during their shift. But yeah, and for the workers, yeah, we had to change a little bit our initial idea because of the difficulties we're encountering.
Thank you, Gemma. Any other? There is another one.
Yeah.
Yes, good morning, Massimiliano Simoni, Telecom Italia. I noticed in one of the slides that there were some countries where you indicated that there was no 5G component in the composition, like I remember one was Netherlands, another one was Italy.
Yeah.
I was just wondering when the measurements were made to understand whether, if it's something that...
Yeah, I forgot to tell you, but yeah, the measurements were done in 2023. So we did a campaign in 2023, but the good thing is that now we are repeating it. So we're doing the same measurements now in 2025. In fact, some of our technicians are doing the measurements right now in some of the countries. So the idea is to also compare the difference in the telecommunication networks and use of the different frequency bands between these 2 years. I'm not sure if you both have any other, I mean, both is involved, but in the measurements, if you have any other comment, or Martin?
Thanks. So it's a repetition to 2023, 2025. We see the differences, like just as an example, Poland had the 2.6 gigahertz bands in 23, and now 2025 they have the 3.5 gigahertz band and 5G. So you clearly see the rollout, in fact. Yeah. We are in Brussels, to give the example. There are also some colleagues, really strict norms. The rollout was also in Brussels almost, there was in 23 no 5G, you could say, or very limited, and now there is.
I think it will be interesting to see the difference between the two campaigns.
Another question?
So I'm not sure if I should ask a question right now or when I'm on the panel, but I ask it right now because it's related to your presentation. What is not really clear to me, how do you find workers? Are these people who are working with 5G installations, or people who are in general exposed to high electromagnetic fields, or people that are exposed to whatever fields during the work?
We ended up just recruiting people that are exposed to 5G during work, but not specifically next to any 5G installations or anything.
Okay.
Yeah.
And the other question, I guess that you focus on mobile communication application of 5G, so it's not about low latency, autonomous driving 5G application, or it's a question of highly reliable networks, because there are different types of 5G application, and I guess according to your presentation you focus on the mobile.
On the mobile, yeah, mainly. Yeah.
Okay, thanks.
Thank you. If there are no other questions, I think...
Online.
Please.
Yep. So we've got an online question. It's a little bit long, so I'll read it out. Is there any data available to link the distance to the radiating structures with the power flux densities measured? Maybe even just min-and-max distances for each result set. The person says, I guess that the UE was quite close to the measuring device, and thus you get the high uplink values, and they say it was very informative.
Not that I am aware of, but the building setup, yes, but yeah, all the details that they're asking.
Yeah, so there is also a modeling task in Work Package 1, and CNR is leading that. And indeed, so the buildings and distances to buildings, base stations, when that's available. So base station locations like in France, Netherlands, Spain, Belgium, you have good access, you know where the base stations are located. Like Italy, it's not known. But buildings and distances and so on are accounted for, but of course it's the radiation patterns and so on too. Yeah.
Okay, maybe I can just add to that. So one of the things I took away from it was base station density is your friend.
Yes.
If you're concerned about exposure.
And probably this also relates to the kind of perception that people have that having a base station close is harmful, but at the end, yeah, and we have to. I think that our mission now is try to communicate this to the people.
Absolutely. Thank you very much. Thank you also to all the colleagues that asked questions. I would like to move to the panel. That is, I'll say, the next session that we have before the lunch. So let me invite two guests that we have today. Dr. Georg Neubauer from the Radio Scientific Advisory Group in Austria. Thank you. And Dr. Alberto Najera Lopez, Director of the Scientific Advisory Committee on Radio Frequencies and Health in Spain. This panel, I don't know if we have a chart, but basically what we will discuss during this panel is what we know and what is uncertainty on scientific research. And we have the scientific coordinator and the coordinator of Goliath that is looking specifically at this topic. And we have two representatives from International Advisory Group. These are groups that review the research that is available and issue a statement on a sort of summary of the scientific research that is available. Before we start, I would like to ask the same question to both Dr. Neubauer and Dr. Najera Lopez. If you can just say a few words describing how your institution works and how do you proceed with the review of science. Shall I first?
Okay, so thank you for inviting me to this panel. It's an honor for me. I'm working for the Scientific Advisory Board for radio frequencies in Austria. It's called Wissenschaftlicher Beirat Funk in German. Since it operates since 2004, and the Scientific Advisory Board has three main tasks: to evaluate scientific evidence on a yearly basis, then to inform the public, mainly based on these evaluations, and also to give consultancy to authorities, in particular the ministry the advisory board is allocated to. As mentioned before, the board is an independent, interdisciplinary panel consisting of, I think, 11, 12 permanent members and some additional other experts that join. Composition changes slightly from time to time. And last year we were allocated to the Minister of Finance. Then we had a voting in Austria, then the allocation changed. And sorry, I cannot remember this by heart. Now we belong to the Federal Ministry of Housing, Arts, Culture, Media and Sports. There are different ways on how to allocate competences to different ministries. I do not want to discuss this in more detail. What else can I say? The main task we're doing is to evaluate the scientific evidence. We have a list of keywords that is adapted on an annual basis. And based on that, the literature research is performed. We get out about for several hundreds, let's say 300, 400, 500 studies per year. Then we make a pre-filtering. We end up with about typically 150, 160 studies per year. It's a rather constant number, interestingly enough. And then the studies are distributed to the different expert groups. So I'm dealing with the dosimetry group. There are the groups on oncology, public health, and so on. So multiple experts. And then the expert groups evaluate the evidence of the year, so to say. In fact, it's year overarching. It's a period of 1 year. And then we present and discuss jointly the outcomes of the work. Based on that, we make a joint conclusion. There will be, and that the outcome or will be then made public and is also presented to the media. So that's what we're doing on a yearly basis.
Thank you very much. Okay, my turn. Thank you very much for inviting me to participate in this panel. I could say just we almost try to do the same as but with little differences. The CC cards can be translated as the Scientific Advisory Committee on Radio Frequency and Health, and we depend on the Spanish official or professional college of telecommunication engineering. This committee was created in 1999. Probably this story that I want to tell, I'm going to tell you, sounds very familiar because it started with a primary school where a mobile base station was installed nearby, and quite a lot of cancer, leukemia in children appear. So in that moment, the access to the information was really difficult. So the University Complutense of Madrid and some experts, some teachers and professors of the university tried to answer the demand of these people in Valladolid. After that, in the year 1999, this group of people formed by medical doctors, oncologists, radiologists, but also telecommunication engineering, physicists, epidemiologists, established with a main goal to be reached every 3 years. We try to publish or to review all the scientific evidence. I am the scientific director since 4 or 5 years ago. So my first objective was that these reviews, these reports, were based on systematic reviews. And our last report, it is about 5 different chapters covering different parts of this problem. And 2 of these chapters were systematic reviews about risk perception and personal exposure. The other chapters were made based on narrative reviews, but the objective is to get all this information and bring it to the public society. Our stakeholders are audience are mainly operators, municipal, technical people from local and regional governments. So we try to recover all this information and to write a report that it is scientific, rigorously written, but also easy to read for a lot of kind of people. We also made some position papers when we detect something is happening. For example, the Goliath is already publishing quite a lot of papers, so very interesting papers, and we want to translate that information to the public and the local governments, that they are the first row in this battle with the movements against this antenna. And we also made a very heavy work in fact checking, because we receive a lot of fake news, and we collaborate with different fact checkers, and we also publish scientific spreading science, probably this platform called The Conversation. We also are trying to publish in that conversation. So that's briefly all what we are trying to do.
Thank you very much. I think it's you have described it very well, and it's a very important role to translate, let's say, the whole bulk of knowledge, of scientific knowledge, into something that then is immediately available for decision maker, but also for the industry in Austria, in Spain, and in all the other markets. I think that it is quite easy to facilitate this session, because we have one key question, that is what do we know and what is uncertainty. Let me phrase in a little bit different way. I would like to ask the same question to all of you. If you compare, I would say, the situation today with a few years ago, is there? Can you summarize, what we know more, and where, let's say, we still have gaps that we have to investigate and to address? Ladies first.
Ladies first. Okay. Well, I think that now, compared to what we knew, like you said, 10 years ago or so, I think we've made a very good job in the exposure assessment, improving exposure assessment. It's not easy, because and you all know that technology is changing, and it's changing very quickly. So every time that technology is changing, we have to adapt, and we have to adapt our methods for the exposure assessment. But I think that we've come a long way in improving the exposure assessment from 10 years ago, and I think that's a very good thing. We also have made some improvements in the methods to assess if there are any health effects. Okay, so we have now we have more methods, and we have learned more statistical methods. For example, in Goliath, we'll try to see and to study the causal effects of RF EMF, if any, with very novel and state-of-the-art methods. And also, in the part of more the epidemiological part, we are using now longitudinal data. So far, most of the studies published have used cross-sectional data. So now we want to see what happens throughout the time. So not studying just one point in time and seeing most of the studies, we're seeing just the exposure and effect at the same time, but now we can see the exposure and the effects later on, so using this kind of longitudinal design.
Thank you very much. Before moving on, I take the opportunity to welcome also Monica. We know that you are listening to us, but it's very nice to see you now also. You are connected on video in the room. So welcome, and thank you for joining us.
Thank you.
Please.
Your turn. Okay. Well, looking from the perspective from the Wissenschaftliche Beirat Funk, I would say over all these years, there's things that are continuously changing, and it's particularly related to dosimetry and exposure conditions. They're changing because if you look at all the research papers, there's, for instance, trend to more and more research dedicated to millimeter waves, so the higher frequencies. There are huge papers dealing with development of new antenna, intelligent and dynamic antenna types, also in the smartphone. So there's a lot of dynamic there. You see, not that frequent, it was one of the reasons why I was asking you the question before, that the other type of mobile 5G applications, like low latency application for autonomous driving, or even highly reliable networks, the research is not focusing too much on them, let's say it that way. For instance, 5G broadcast may arise in the next years as a one-to-many application, but so far you don't find, at least we didn't find any paper on that, that exposure scenarios. That's one thing. And the quality of the dosimetric study in general terms is good, most times very good. If you look at the medical studies, my colleagues to deal with that complain since many years that the quality of most of the scientific papers in that area is rather poor, and they use other words from time to time to express that. So this is unfortunately a certain constant, as this complaint about lack of quality in many studies, medical studies. And so I would say, all in all, from the biological medical side, I do not see too many changes, but the exposure conditions, the evolution of new technologies changing rapidly, and hand in hand with that, you see also a very dynamic change in the way exposure is assessed. So it goes, in the meantime, you have a lot of studies dealing with AI as tool in order to model exposure and things like that. So that's a very dynamic part. And
I think it's very relevant, especially in the telecommunication area, where the technology evolved at such a speed that it's very, very impressive.
The technology is changing, society is changing, so we have to still continue researching and trying to find these gaps or these uncertainties. I think Martin and Josh just said what are these gaps before, and I think that 30 years ago we was not able to say that that there was no link, but now with 30 years after that, we have a whole set of different papers, a very huge amount of information, and I think we can. I cannot say to the public this is 100% secure, because we are scientists, and we cannot prove, as Martin said before, we cannot prove negative phrases. We cannot prove that there is not a teapot orbiting Mars that control all of us. We cannot prove that it is false, because we cannot prove negative sentence. So the main part of our future is how to communicate these uncertainties to the public. How can I say to the public, you can be okay, to the typical personal exposure levels, you can be sure it is no effect, not 100%, but I'm a physicist, so for me, 99.999 is 100, because I'm a physicist, but not if you are a statistics, you cannot say that. So that is one of the main part, but with 11 systematic reviews already published by this grateful project that the WHO has done, I think we are in a higher level than we were not 10 years ago, that we were 2 years ago.
I think this is also very, very important, the fact that it's not 10 years, but just a couple of years in terms of improvement. Thank you very much for this first round of answer. And now, time for your question to the panelists. Please.
Thank you. Hamish McLeod from Mobile UK. We heard from Martin in the previous session that unless we improve markedly the methodology, we're not going to learn an awful lot more than what we already know. Now, in the UK, Imperial College are about to start or have requested the next batch of user data for their the next phase of the Cosmos study. We're going to sit down with them in a few weeks' time. What would do you have any constructive suggestions as to how, what user data would provide better insights?
Well, speaking, for example, for Goliath, right now what we are doing is asking people on how much they use the devices, either mobiles, tablets, etc. But this can be really, well, I'm not going to say misleading, but for sure it's not the reality. So I think having real data will help us to really understand how many, let's put an example, how many hours people are calling on their mobile phone, and then from that, and using all the information that comes from the monitoring, from all those modeling, we can really get a kind of, I think, I would say a more accurate dose model than we have with estimations. We've been, what we have seen so far, for example, looking at the data that we have collected with the survey, is that there are, for example, the survey that we did with the young people, there are people that report using their mobile phones 12 hours a day. So is this, I mean, yeah, this is the data that we have. Or for example, in Work Package 2 in Goliath, with all the cohorts, we ask all the participants in the cohorts to report their use of their mobile, their tablet, etc. But having real data would be much, much better. So I would encourage to do that. For most of the studies, it's very difficult to find this data that you are going to provide to Cosmos, for example. So it would be great if all the studies that we are running, we could have this data. So because it's real data. The thing is that now, this is part of the data, but the second part of the information that probably we don't have with that is if they call, for example, do they use headphones? Do they use where they have the device position? So do they have it in the ear? Do they have it in front of them, etc.? So this is something that we cannot get from the data that you're going to provide, but we can get the data on calling time or use time of the device.
One thing I had raised before is that it might be worth it to also take a look at other sources of exposure, particularly when looking at a small group of workers that might be exposed to higher field levels, occupational exposure. There are not too many, but they exist. The other things is that even that mobile communication exposure might be affected due to the fact that you sit next to an access point and you're not aware of it. If you only ask people about the use of the mobile phone, they might be exposed to some other radio frequencies just nearby, that are nearby. The question is, you either want to look at addition to the low frequency exposure, because then it's getting more complicated, because then you have a lot of hidden sources. So far, if you look at the exposure side, the other thing is if you want to consider the psychosocial effects, it's more complicated. It's not really my domain, but it's. I think that the concerns that people have affect also the way they perceive their exposure. But there are a lot of experts who are better suited to dive deeper in that domain. So that's more or less my 2 cents first round.
As it has been said before, mobile phone use is not exposure. It is related, but there are quite a lot of variables. My research group, I have a little research group in Spain, and we try to to measure personal exposure with personal exposimeters. We had 100 volunteers in our little town in Albacete, in Spain, and we measure every minute during 24 hours, just asking to these volunteers where they were at any time, at home, at work, in mobile, in the bus, on the street, all the different kind of sources, radio frequency sources, Wi-Fi, all these kind of things. It is a very, very hard work to do, but I think it's the best way to assess. But it depends on the people who participate also. So we have a lot of variability. So even in that case that we can control much more of these variables, it is very difficult. We also are measuring environmental exposure. We measure in a fair that we have in our town. It is 10 days fair. More than 3 million people come to this fair in a very close and a very small area where a lot of temporal mobile phone base stations are installed all around this area. So we also measure in that conditions, in the worst conditions. We did it 4 years ago. No 5G was installed, and we did it last year, and we forced 5G connection with mobile phones. So I think we need all these different approaches to find what we have, and that's the difficult way to do it. And this is, I think, one of the uncertainties that we have to face in the future.
Thank you very much. I'm sure this would be incredible, valuable input also for the UK request that you are managing.
Hello, Christophe Granja from Nokia, EMF mitigation lead. I have a question on these microenvironments that you are using in your studies. What are the criteria for selecting, and how do you address bias in selection in the analysis, and how it can impact conclusion?
I don't know if you want to answer, Martin, or I can give you a brief overview. So these are for each of the cities we ask, or for each of the countries we ask the local research team to select the environments based on some criteria that we have in our protocols. Of course, we are aware that there might be slight differences between countries and cities, but we try to homogenize using kind of a standardized and harmonized protocol for everyone. This is, something that in all studies, it's something that we have to take into account. Doing the same thing in different places, exactly the same thing, it's very difficult. But I think with the harmonized protocol, we're doing our best to have these microenvironments as similar as possible in the different countries.
Maybe to add, we really focused on the functional, on the function of the area. So we didn't look into like base station density to avoid this type of selective things. And so in that sense, I would not talk about bias, but obviously there's uncertainty, and as we could not measure everywhere. So a small town, I don't think there's a big thing in big cities. There basically you have a relatively homogeneous exposure, more or less, and it doesn't, we have done such tests, it doesn't matter too much whether you walk here or here or here. But in small cities with less infrastructure, there's a bit more variability, which may explain some of the differences. But this is just more or less chance. I think as long as we don't talk about health, and as we don't think this is really representative for the country, I don't want to talk about bias in that sense.
And we are doing quite a lot of measurements, I explained before, and also Martin, so we're doing quite a lot of measurements in different microenvironments, different cities, different times, and different scenarios. So this gives us kind of more robustness of the data that we are collecting. With this kind of uncertainty that we always have in science.
Thank you very much also for the question and for the answers. Perhaps we still have time just for one question, or?
Yeah, so this is an online question. So most of the results you presented so far relate to exposure measurements. Clearly the biology is still underway. So it seems like the biology will miss the deadline for the WHO systematic review and task group conclusions. So how do you see Goliath contributing to future risk assessments and maybe reducing the uncertainty that expert groups like Austria and Spain have identified?
Yeah, we are, let's say we're always late. Technology is advancing too quickly, and we researchers try to catch up, but we are, we can phrase it like that, we're always late. But I think that every time that we do a study, we try to improve the methods that we have previously used. So this will give us some more knowledge on how to face the next generation of technologies that will come. But it's something that there's not much that we can do. I mean, you can see as presented these measurements we did in 2023, we're not doing in 2025. Now we have to build all these RF, EMF, those model, and then apply this model to the biology or to the epidemiology or biology. So yeah, it takes time, but we learn. So with every study, we keep learning, and we keep learning what were our limitations, our previous study, and then to apply and to try to overcome these limitations for the next phase. But yeah, that's something that it's inherent to research. It takes time.
Can I just ask, maybe follow up to George and to Alberto? So you both mentioned that there are issues in quality in some of the studies that you've seen. Are you confident that Goliath will give you clearer answers, that they will address some of that quality issues?
From the presentation I saw, I'm optimistic.
Yeah, we put all this information together, not only Goliath, Cosmo, the 11 systematic reviews and meta-analysis. It is important that these systematic reviews also include this meta-analysis. If we put all this information together, I think we have a new set of information that is strong. The effort that the WHO has made, I count more than 90 scientists, multidisciplinary, multinational scientists making these systematic reviews. So we have now a set of knowledge. We are in, as I said before, in another step. We have to keep going. We have to improve our technical with, like they are trying to do. And science is not 100% certainty. So we have to stay still researching and working.
And what, just to briefly add that I think that one of the things that Alberto mentioned is the multidisciplinarity, especially in this field. We need multidisciplinary groups to try to understand. So we have the engineers, we have the epidemiologists, so we have all the basic researchers. So we have to understand each other because let's say we talk different languages, but I think we come to a point where we understand each other, so we can just put our knowledge together to get the result.
Thank you very much. Thank you very much to all our panelists for joining this session. It was very, very useful. Thank you again.
Thank you.
Thank you.
And with that, I will open the floor to Isabel Alvaro from Telefonica and member of the GSMA EMF and Health Group. Isabel.
Thank you, Jack. So now that we all have returned from the lunch break, I welcome you to this new session on risk perception and risk communication. To begin, I would like to invite Professor Ursula Soler from the John Paul II Catholic University of Lublin to join me here on stage to present her paper on Polish attitudes towards new technologies, awareness, emotions associated with electromagnetic fields. So please, Professor. Thank you.
Hello, thank you so much for this nice invitation. I need to make some changes because till today I'm from John Paul II Catholic University of Lublin. From tomorrow I'm from Warsaw University Life Sciences. I'm changing my affiliation from one day to another. That's why in my presentation you will find another one. And this topic which I would like to talk today, it's not only about Poland, but it's wider about also Germany and Japan. I'm a sociologist working for many years with technologies. We are trying to understand, we researchers, how technology is changing societies and what we're supposed to do, how to help our societies to deal with technologies and to use them in the way that it will help to also grow, to develop societies, and how to help them not to be so worried of this very fast developing. Here is the topic of our research. As you can see, we are a group of researchers from 3 countries, Germany, Japan, and Poland. For the first time last year, we decided to make this research in 3 countries, to make this comparison between 3 countries, how people perceive EMF technologies and what they are afraid of when we're talking about 5G technologies and telecommunication technologies by itself. I don't have to explain you why it's so important because you are specialists in this matter, but for sure you understand that developing of technologies is much faster in last years than development of societies. Our societies are not able to follow that fast. They're not able to change that fast as technologies are changes, which, as you can expect, cause a lot of protest because people don't understand, people are afraid, people don't know how to deal with it. So from the one side, they're happy that this big development of technologies is going on because they have better life, they can use different things that help in everyday life. But from the other side, they don't understand, for them it's too fast. They have a lot of concerns about their health, the kids, and the general situation. And from the other side, we have also huge disinformation about this matter. For sure, you know also that very well, mostly coming from Russia, which is not helping in perception, proper perception of technologies. So stopping our societies in development in correct way, like we would like to do. So last year, we, together with Japan and Germany, we signed an mutual agreement of understanding for this specific research. But this is not the first research for Poland. We already conducted twice this kind of research, one in 2020 and the other in 2022. So for us, it's the third one. Thanks to that, we can have some comparison and see also changes in our society, in Polish society, how we change. We would like to conduct another survey next year. We are inviting also other countries, other continents, because for now we have only 2 continents. The third one is incoming. So if you know that your countries would like to join us, you are more than welcome. So I will make some publicity now when I have a word. Okay. So as you can see, our methods was different in different countries because our countries are different and we have different populations and different develop of population as well. So Japan is a huge country with huge populations, so they had to make a research in 6,000 Japanese. Germany had a group of 2,000 and Poland, for Poland it's enough 1,000 citizens to make this representative sample for the country. We also use different methods because we decided separately that our countries are different and different methods will work for us. So Japan used only computer-assisted web interviewing, KAWI, so they made everything via internet. Poland, because our society is getting older, so we decided that it's not enough for us to use the internet because older people will not participate in our research. That's why we decided to go to home of people and ask them directly what they think about different manners. And Germany decided to use telephone surveys. In our survey, we had different categories. First one was risk perception related to EMF. Second, levels of scientific understanding of IMF. We wanted to understand what people know about IMF by itself. Third, levels of trustworthiness of IMF risk information. 4, expectation towards the sources, organizations, persons of IMF risk information. 5th, risk perception other than EMF, so what people are afraid of a part of IMF as a population. And the last one was other characteristics. Some of them I will show you here. Generally, our survey had 2 parts. One was general, which was exactly the same for 3 countries. And the second was specific, that we wanted to ask specific questions to our population, which, for example, a bit different for Japan than for Poland. Here I will present you only the general part, which is exactly the same for 3 countries. So we had exactly the same questions, and we asked about those matters exactly in the same way via different canals. This is for the first slide. I will show you a lot of data. I'm not sure, it's too small. I know you can't see exactly what is written there. I didn't expect that it will be small screen, and I wanted to show you this data. You will have the presentation, so you can go deeper in it, but I will explain everything. I will explain how those slides are made to show you what you can expect. So on the right side, you will see a group of different answers for any question. And you have 3 different colors. Green is Poland, blue is Germany, and black is Japan, to show you what is the size of answer for any question. On the left, you have index, and on any slide you will have index. This index shows us on which level any country is for any kind of risk. So for example, here you will see concern index. So what is the level of concern of any population about different manners? As you can see, Poland has its biggest concern here. And on the top, you will see answers that were the same in different countries or were most important for different countries. Yeah, I know that I have to read everything now because you are not able to see. So the first question was, to what extent are you currently concerned about the following issues? So what you are afraid of? And answer were nuclear power plants, X-ray radiation diagnostics, high voltage power lines, electromagnetic waves, artificial UV radiation, radon, magnetic field, electromagnetic field, electric field, mobile communication base stations, ionizing radiation, generally speaking, natural UV radiation, so sunlight, microwave ovens, e-mobility, like, for example, electric cars, radiation during flights, Wi-Fi, mobile phone headsets, television or radio signal, induction heating, like, for example, stove, household electrical devices, and electronic article surveillance systems. As you can see, country which is afraid most is Poland. We are concerned of many things, and our concern index is 58.3, Maximum is 105, so we are more than half of the level of concern. There are many reasons. There is no space to talk about this now, but yeah, we are worried. And what we are worried for? All three countries are really worried of nuclear power plants. Here, probably, for Poland, the biggest reason for sure here is Chernobyl. For Japan, of course, is Second World War, Fukushima and Nagasaki. And for Germany, I suppose, is mostly disinformation. But we can only suppose that. Second is X-ray radiation, both for Poland and Japan, and here also history is coming back. Then high voltage power lines is important for Poland. Artificial UV radiation is also important for every three countries. Electromagnetic waves are afraid only Poles most. But what is really interesting, Poles are not afraid of sunlight. But countries which are afraid of are Germany and Japan. So here probably we have level of education, which is important as well. What is interesting, Germans are really afraid of mobile phone headsets. We don't know why, maybe German will discover that. And then ionizing radiation, the country which is afraid of is Japan. Okay. Here, the second one, we have knowledge about sources of EMF. The question was, which of the following devices or phenomena do you think are sources of electromagnetic fields? And here we have desktop and laptop computers, wind turbines, mobile communication base stations, high voltage power lines, modems, routers, signal boosters, household electrical devices, photovoltaic installation, Wi-Fi, sun, e-mobility, mobile phone headsets, electronic artificial surveillance, and electric sockets. As you can see, different countries are afraid of different things. But here we have Germany with really big problem with mobile phone headsets. But generally, the most important for our populations were high voltage power lines and mobile communication base stations, which is really important information for all of you, I suppose. Also, household electrical devices are in our top 3 for our countries. The third important questions, and this is, I think, really important questions, was about health effects caused by EMF. So we are not asking about real health effects. We were asking what people think that EMF could cause. So for the first, we have headaches and migraines, insomnia, concentration problems, brain cancer, harmful health effect during pregnancy, other cancers, infertility, cardiovascular problems, childhood leukemia, hypersensitivity, depression, genotoxicity, genetic damage, and allergy. And what is really surprising, maybe, is that for Poland, Poles are really convinced that EMF causes brain cancer and other type of cancers. We don't have this problem in Germany and Japan. For them, headaches and migraines, insomnia, and hypersensitivity. So these things that we could feel somehow and say that we can feel it because of EMF. But Polish people are really convinced that brain cancer and other type of cancers are caused by EMF. What is also interesting, you can't see because it's little, but 28 of Poles thinks that also allergies are caused by EMF. This is pretty surprising data. Okay. Then we also ask our respondents about trust. In what kind of sources of information they have trust, to see also in which way we should communicate with them in proper way to reach the goal, which is information about EMF. The first one is scientific journals, books, and publications. Second, television and radio, internet, generally speaking, brochures and similar materials, social networks like Facebook, Twitter, and so on, Twitter X, quality newspapers and magazines, and the last one, tabloid newspapers. And here, what is important, what you can see, that Germany is the country that really trusts in scientific sources. The difference is huge between Germany and Poland and Japan. So Poland is more concentrated, and this is a big problem for our country, on social media. 28% trust to social media about this matter, which is terrible information for us. And also to tabloid newspapers, which is also very bad information for us. Germans trust to scientific journals and quality newspapers. We want to be like Germans. Then we have trust in institutional sources of information. So not media, but institutions. In which institution we have trust? And possible answer were universities or public research institutes, international organizations like World Health Organization, local government agencies, institutions, third sector organizations, NGOs, different kind, civic movements, which can be anything. This is also a big problem. National government organizations and companies operating in areas related to electromagnetic fields, so your companies. And what is the answer? Luckily, most of our answers were for universities. This is very good information. Of course, Germans trust the most to universities. They also trust a lot to national governmental organizations. But what is the bad information for all of you, that less than a third of populations, is every population that we made a research, only 1/3 trust to telecommunication companies. So more than 60% of those societies don't trust telecommunication companies in information matters. And then we had also personal sources. So what kind of personal, who need to talk to us to have our trust? At the first was scientists and experts, doctors and nurses, healthcare professionals, family members, friends, teachers, and municipal office employees. Luckily, still luckily, at the first place we have scientists and experts, mostly in Germany, but also Poland is not that bad. As you can see, in any single diagram here, Japan is pretty low, which was a bit surprising for me, because level in Japan is really low, generally speaking, to different sources. Probably Japanese could tell more why, what is the reason of that. Still, we have trust to doctors and nurses. It is growing. For Poland, it's growing because after COVID, we had very bad situation with trust to doctors. Now, luckily, it's gaining again our trust. And for Poland, very important is also family members and friends, which is connected with social media. We generally trust to people we know, or maybe we suppose that we know, which is, of course, dangerous because it's easy to spread disinformation. Then we also wanted to ask people what are the preferred media sources of information to understand in which way we should talk with them. So what they use most. Television and radio, internet, scientific journal, books and publications, brochures and similar materials, social networks like Facebook, quality newspapers and tabloid newspapers. As you can see, Germany again is using, to gain information, is using scientific journals and quality magazines, and Poland and Japan, unfortunately, not. For Poland, it's mostly television and radio and internet. So we don't like to read nothing which is really complicated. I think the most important part that the language is not really correct for people to reach them. Yeah, we're discussing this for many years, that scientists are talking in the way that people are not able to understand that, which is a pretty big problem. Okay. And then institutional sources, and again, Germany would really have more information from universities, national government and agencies, local government and agencies. As we can see, Germany has big trust in government. I think it's not really common in the world, but it's very good information for Germany from one side. From the other, can cause different risk if this trust to the government is also too big. For Poland and Japan, they trust too much. Poland trusts too much to civic movements. Why it's dangerous? Because civic movement can be anything. So it's also a big source of disinformation. And we can, because I'm working also with disinformation, and we can observe that there are the same groups of civic movements which are spreading disinformation in different fields. So health, technologies, COVID, vaccines, and so on and so far. And it's going pretty well. For Japan, as you can see, generally, distrust is also to the institution is slow. They don't want to have this information from institutions, mostly. I don't know if they're not interested or they don't want to think. It's really difficult to understand. And personal sources, again, Germany would like to have more information from scientists, from doctors, and from family members, which is strange. For the first time is shown this number, 42%. Probably they think that their family members are well educated and have the knowledge. It's a very big number for Germany. And Poland and Japan mostly trust also to family members and municipal office employees. We have problem with education. The last number is for teachers. We don't want to have information from teachers. Any 3 countries is maximum 34% of respondents that would like to gain information from teachers, which is very bad information for our educational systems. Another question was about sources of concern. So what people are afraid of are part of EMF, what we are worried about. The first answer was pesticides, then genetically modified food, unprecedented natural disasters, air pollution, multi-drug resistant bacteria in hospitals, nanoparticles and plastics in food and water, road, rail, and air accidents, effects of vaccinations, processed meat, red meat, tobacco smoking, including so-called passive smoking, alcohol consumption, and noise. What was surprising for me as a scientist, that mostly Poland and Germany are afraid of pesticides and genetically modified food. And Japan is mostly worried of smoking, even though the percentage of smokers in Japan is the lowest from all of those countries. And they're also worried of accidents, different kind. They are not worried of pesticides that much. They don't care that much about other things. Yeah, but people mostly worry. Also, Germany worry a lot about multi-drug resistant bacteria in hospitals. This is new problem. And in Poland, very important, connected to this information is effect of vaccinations. Poles are really afraid of vaccines. And we see this problem bigger, growing and growing, because we have some diseases that are coming to our country. And we start to have this big problem how to combat this disinformation, because we have real epidemic problem with diseases that didn't exist anymore in our country. From one side, the reason is the problem, the lack of vaccines, and the other is war in Ukraine and the fact that a lot of refugees from Ukraine came without vaccines as well, bringing also different diseases to Poland without any control. It was difficult wartime, and it happened like that. But Poles are really afraid of vaccines. They don't want to vaccine children. They don't want to vaccine themselves. And it causes, as you can imagine, a big problem also for whole Europe. Then, to understand how people generally work, we ask them also about the interest in technology. To what extent are you interested in technology? I was expecting that the biggest percentage will be in Japan. Generally, Japan, in my way of thinking, is a technological country, really developed in technologies, and I was expecting a lot of positive answers in Japan. But as you can see, surprisingly, Japan is not really the green color interested in technology, only 33%. Biggest interest has Germany, 51, and Poland, 30. Poland has mostly ambivalent interest, and this is because of two reasons. One, they would like to use technologies, but from the other side, they're afraid of. So we have this difficult situation inside Poles. Yeah, so they want to use it, but they worry of use it, and they don't want to do. After, we ask also a respondent about self-assessment of technological competences, and this is also a big surprise for me as a researcher. As you can see, Japan, only 8% answered that they are familiar with technical matters. 8% of population. They use technologies, but they think that they don't know them. They don't know how to use them. For me, it was a huge surprise. Germany, 40%, and Poland, 28%. And the next, attitude toward technology. What is your attitude toward technology? And again, Japan, only 11% is enthusiastic with technologies. They use it, but they don't care. I don't know. And 47% is skeptic. So they use technologies, but maybe they don't want it anymore. Poland, 36% is enthusiastic, and Germany, 44% is enthusiastic toward technologies. Then we also asked about knowledge about the strength of EMF impact. So the question was, an electric, magnetic, or electromagnetic field can be emitted by power lines or radio antennas. In your opinion, how does the strength of this field change in the distance from the current-carrying conductor, or the antenna is doubled? So we wanted to see the real knowledge of our respondents about physics, generally speaking. And as you can see, the correct answer, which one is? The first one is the strength of this field doubles. The blue, the strength of the field decreases by half. Green, the strength of this field decreases to 1/4. Strange green. I'm not sure. And it's violet, hard to say. Which answer is correct? Quarter, of course. Quarter is correct answer. As you can see, Germany is the best educated population from those we were researched. 32% gave the correct answer, 12% of Japanese, and 10% of Poles. Maybe the reason of different answer is also the way that they could check answer of the question. Maybe Japanese could do that because it was internet survey. Poles couldn't because they were face-to-face conversation. Germans by phone, maybe they could also check it. I don't know. It's difficult to say. But for sure, they use scientific journals, they trust universities, and probably they have bigger knowledge than other countries. Okay. Another question that we wanted to ask was the question of acceptance. So, would you agree to the construction of mobile network antennas within 500 meters of your place of residence if it increased your mobile network coverage? So we ask people if they would agree to build antennas if they would have better field in the phone. And as you can see, Germany answered mostly yes, almost half of the population. Japan was a bit lower, but Poland is really skeptic. 42% will not accept building antennas within 500 meters from their home, even though it would help with internet in their phone. From the white side, they would like to use technologies. They would like to have, they are scandalized if they don't have internet in the phone, bad connection, and so on, but they don't want to have it close. We have this typical, we call it in sociology, NIMBY effect. So not in my backyard. We want to have it, but no, not close to me. We have the same problem with different kind of infrastructure, so power plants or burning plants and so on, yeah? So we want to have it, we want to use it, but far away from me. I'm not talking you good about my population, but it's the truth. The last question of perception, we wanted to also see what really people think, how they feel science and technologies and what they have all around, was a question about perception of distance of the nearest high voltage power line, because we are afraid sometimes of power lines. So what do you think is the approximate distance from your place of residence to the nearest high voltage power line? And as you can see, Japanese couldn't answer. 66% didn't know. Probably, also, again, probably the reason is that it's huge density in this country and it's difficult for them to tell it. It's really difficult. 65% of Germans says that it's more than 200 meters, and 34% of Poles say that it's more than 200 meters. Mostly we are thinking that is less than 100 meters. So we had this perception that they're really close to us, so they're dangerous to us because they're a source of EMF radiation. And last question, but for me, a really interesting question and also interesting answer we discovered, was about use of EMF preventive measures. So the question was, what preventive measures, if any, do you take to reduce exposure to electromagnetic fields? So we ask people how they protect themselves to EMF. And you can see it easily that it was, for me, pretty surprising as well, that Germans are protecting themselves mostly. Answer were, I grow potted plants. I leave my mobile phone outside the room when I sleep. I avoid sources of electromagnetic fields. I turn off my phone. I turn off Wi-Fi at night. I permanently switch off radio or TV. I don't use the standby mode of such a device. I turn on airplane mode on my phone. I operate emitting devices remotely. I use protective measures, like, for example, anti-electromagnetic blankets or appropriate clothing. I use radiation absorbers. None of these because the electromagnetic fields around us are not harmful to health. I don't use any of these because of different reasons. As you can see, when I saw this data, I was happy that Poland and Japan are on the same level. For me, it was, wow, Poland is second Japan. We will be technological power, yeah? Because we don't use it. But after we start to go deeper, try to understand why. And as you can see, I will show it here, the red down there, 37% of Japanese said that they don't use anything because EMF is not harmful. So what's the reason to use it? And only 17 of Poles said that it's not harmful. So Poles probably, they're afraid, but I suppose that they're too lazy, maybe, to use it. Still, I'm not talking good about my society, but this is the truth. Germans are not really afraid, but they use a lot of protections. Why? We don't know that. So they grow plants, they leave mobile phone outside sleeping room, they switch off their phone during the night, and so on and so forth. They do most of it. You can see it, it's yellow, which is also pretty surprising. Probably this is also a characteristic of the society, that they're really organized and order people. So someone told that they're supposed to do that, so they do that. They're not revolution societies like Poles are. So some conclusions, some most important, here you can see a bit more, some more most important summarize of this research. Concern about EMF. Poles are more worried than respondents in Germany and Japan. In all three countries, nuclear power plants and artificial UV radiation are among the top 5 concerns. Only in Poland, electromagnetic waves and high voltage power lines are in the top 5. Acceptance of infrastructure, highest in Japan, so Japanese would like to have infrastructure close, lowest in Poland. We don't want it completely. Perception of IMF sources. Japan, least likely to see studied devices phenomena as IMF sources, so they don't harm us. Top 3 in all countries, high voltage power lines, mobile base stations, which is bad information for you. Country specifics. For Poland, sources of IMF are computers, monitors, and TV. For Germany, mobile phone headsets, still I don't understand that. For Japan, household electrical devices. Perceived health effects. Poles attribute more negative effects than Germans or Japanese. Top 3 in all countries are headaches, migraines, and insomnia. And specific for Poland, and this is something that we need to worry about, is brain cancer as a reason of IMF. Preventive measures used mainly in Germany. Trust in sources of information. Poles trust media and personal sources more than Germans or Japanese. In all countries, scientific journal, books, and publications enjoy highest media trust, luckily still. Germany, highest trust in institutions. In all countries, universities and public research institutes top trusted institutional sources. Scientists, experts, and healthcare professionals are the most trusted personal sources everywhere, still luckily. Preferred channels of information. For Japan, calls for more information from all 3 types of sources. As you could see, they don't trust too much to any kind of sources. This is for me something really interesting to follow, to understand Japanese society as itself, why they don't trust generally. Poland and Japan, preferred channels are mostly television and radio and internet. Germany, scientific journal, books, quality newspapers, magazines, again, best educated society. In all three countries, universities, international organizations, scientists, experts, and healthcare professionals are desired sources. And I would like to conclude like that, leaving the floor to the discussion, because I think it's a lot of to talk about. Thank you.
Very much, Professor Soler. Now it's time for questions from the audience, which I believe you will have. It has been such an interesting presentation. So, are there any? Or, yeah, do you?
Yes, I have an online question. I've got a whole lot of questions personally. I could have stopped you after every slide to speculate. But the online question is that it seems like Poles are worried in general about everything. And do you think this is an artifact of the survey, or is this a situation in Polish society because of maybe geographically where they are or other developments in the country?
Yes, it's correct question. Polish society is not simple society because of many reasons. Of course, our geopolitical situation is not simple, and it causes us not to trust too much generally. We are afraid of many things. We are afraid of war, we are afraid of diseases, and so on and so far. But also, we were under the strong disinformation for many, many years. All of European countries, but maybe Russia were preparing for war, so it was trying to influence more those countries in Central Europe and Eastern Europe. And then we have a problem with trust to our institutions, also because of many reasons. Poland is growing, is wonderful country to live. Really, I was talking badly about Poland here in this survey, but it's wonderful country to live. It's growing in wonderful way, but people are really afraid of many things because they survived many different things in the history, and we remember that still. My generation remember a lot bad things already, still. So I suppose this is the reason. And maybe one of the problems is our educational system, which is not perfect because we are still in this Prussian way of thinking about education. We are trying to fight with that for many years, but it's not that simple because our education has not enough money. We don't have the best teachers because there is no money in it, and so on and so far. And also our government doesn't want to change that much. Those changes are not going fast enough to change society in the way that we need it.
Thank you. Are there any other questions from the audience? Yeah, please.
Thank you very much for this great presentation. I had a first question about this MOU you were speaking about, making publicity for that. So it was 2 years ago it was signed. Yes. So I had the question, at which level of the country is it signed? Is it from the government or from universities? And what's at the end, what's the first results, and what real impacts it may have in terms of better voice communication, maybe?
So we signed it in different levels in different countries. In Germany is a public administration, so a national agency. As we saw, it's important part of Germany. In Poland is NGOs organization at the end, because it's Polish Chamber of Information and Telecommunication. And in Japan, it's also an agency connected with government. And for the first result, we publish first result of this research during the BioM conference in June. It was the first time. Here is for the first time I show you the real data presented in presentation. We plan to publish, or at least write 3 articles within next year about this research and publish them on international level. We would like to have another research, repeat this research next year. And we would like to repeat it every 2 years to see how it changes. And of course, spreading also this in different countries to have more countries to compare, because it's really important to see differences and how to talk to people and what is in common, what we could find that could reach different societies in the same way.
Okay, yeah, please.
Thank you. That was very interesting. But with regards to Poland, is the flow-on of the concerns of the community reflected in their lack of take-up of technology? So are they using technology a lot but still concerned about it?
Poland is a strange country, always was. We use a lot of technologies. And I would say that we are pretty, it didn't show in the research, but we are pretty enthusiastic about technologies. Of course, it depends of groups. I am leading also different research about technologies, generally technologies, not only IMF. And what is interesting, the group which is worried about, is afraid of technologies, they are young men in little cities and villages. Young men, which is pretty interesting. Why? They are afraid. But people, young people, but not only young people, also our elderly people are really trying to follow technologies because simply they found it useful. Of course, we are far away from Estonia or Latvia in technological development using in everyday life. But my mother, which is almost 80, are buying on Temu and doing everything online. So we are trying to follow. It depends also of personal matters, but we like I would say that our generations like technologies, but I see lack of education about technologies. We don't have a subject of technological education at schools, and we're supposed to have it. It's so necessary for children to know, to understand how to use technologies in proper way, because for us it's good, but we need to know how to use it in a correct way. So it's a matter, of course, of cybersecurity and so on and so far, and use proper technologies to help them also to develop themselves, not only to have fun with technologies, because it's not only the one reason to have it.
Thank you very much. I think that we don't have any other questions. No? We can go to the second segment of this session. So thank you again, Professor Soler, for the presentation. So please, we are now moving to the next panel on national experiences in addressing public concern related to base station seating. I would like to invite to join us to the rest of the speakers. First, Margrit Kropik, Manager Director of Forum Mobile Communication Austria. Please, Margrit. Then also George Stefanopoulos, Digital Health Governance Expert of the Greek Mobile Operators Association. Please, George. Thank you. Lisa Kelly, National Manager of Regulatory and Community Engagement at Optus. Thank you. And Hamish MacLeod, Chief Executive of Mobile UK. Please, Hamish. Thank you very much.
So just before the panel commences, you see the poll QR code. If you could answer the second question, as we said, we'll share the results in the wrap-up today. Thank you, Isabel.
Thank you, Jack. So, Professor Soler, since you have just delivered your presentation, I would like to start the conversation by asking how important do you think is trust in authorities in shaping the level of public concern about IMF and base station deployment across different countries?
As we could see in the research, it's really important on the basis, based on the Germans' answers. When society trusts to the government, it's much easier to make changes. And this is, I think, the most important part. If you don't trust your government, your people that you have chosen to lead you, it's difficult to do anything at the end, yeah? Because even though you will try to implement something, people can always protest. For sure, remember that there were some examples of burning telecommunication masts in Italy, for example. Even though it was no 5G there, they were thinking that they were burning 5G base station. And in the same time, they wanted to put it online by their phone to show that they're doing. So they were using technologies to destroy technology, the same technologies that they were using. So people don't understand technologies. They don't understand and they don't trust people who tell them that they should do it in a certain way. This is the biggest problem, I think.
Yeah, and also because technology is evolving, so new concerns are being raised, no? For example, for 5G. So this is an open question to all the panelists. Considering the overall advancements of 5G rollout, how would you describe the public perception of IMF in your country compared to 10 years ago when 4G was still young? So maybe we can start maybe from left to right with Hamish. Oh, okay.
Yes, well, I mean, on the UK side, I mean, you mentioned the burning of the masts. Actually, when COVID came along, we had a perfect storm of COVID and the start of the 5G deployment. And our masts were attacked very extensively. In fact, we had over 200 masts attacked through arson. So we really had to do something and to get a little bit more, calm the situation down. And we decided not to have a sort of public communication, but to go via our local authorities. So we had this sort of concept of the digital champion and getting information to people that was authoritative, but that wasn't coming directly from industry. So we provided the basic information. We called it our 5G Check the Facts campaign, but it referenced out to international authorities, bodies like the World Health Organization and things like that. But we were communicating that directly to local authorities because it was a much more manageable channel. And also they were at the front line. They were having to deal with planning applications when we were rolling out 5G and things like that. So it was really important that they were confident. And I went to a few public meetings and I was very happy to see that there were elected members of local government or appointed officials that were actually acting as spokesmen for what the actuality was. I think the other big problem we had was that on the search engines, if you said are there concerns about 5G, it was completely dominated by the scaremongers. So we had to use all the SEO techniques to make sure that we got information out there and that the authoritative bodies were coming at the top of the search engines, not the scaremongers. So I think just to talk a little bit about the outcomes. I mean, when we started our campaign, we did a short survey. There were, I think, 15% were hardcore 5G is harmful, about 40% were concerned, and about 35% weren't concerned. So we decided our campaign would sort of target that middle group of the convertibles, and post the fact that concern group reduced by about half. So we were very happy with that. Whether there was a direct cause, I don't know, but anyway, we were very, and certainly the mast burnings have considerably reduced. We've got a little bit of a problem in Northern Ireland at the moment, but there is a much calmer situation. When people are objecting on planning, it tends to be much more about the visual impact than the health concerns. So again, that is a massive win from our thing, and the search engine side of things is also much better at the moment.
Thank you very much. Lisa, to Australia?
Yes, well, I think we faced very similar circumstances, probably not to that extent, I wouldn't think, definitely with regards to vandalism. But definitely through 5G, we came out with some very strong messages. Our government put out some very strong messages, and during COVID, even our Chief Health Medical Officer came out and made a public statement, which was very unusual and assisted us greatly. But I do think the lockdowns and the use of technology and everyone's reliance on it probably won out in the end and really calmed down 5G concern. It's simmering away. There's pockets of it, especially in some communities that might be, designed around escaping technology and going to rural locations, for example. You will see it pop up there. But generally across Australia, our 5G upgrades have gone on pretty much unopposed.
Thank you for giving me the floor. I come from Greece, a country where up to, including this year, we've been designing networks at reduced EMF exposure level. From the onset of the industry in Greece, we were operating at 80% to the international recommendation, and since 2006, down to 60% in the urban areas. We hope that by the end of this year, we will have harmonized limits. How we reach that is a very long story, which is difficult to describe it in a few minutes. But let me take you just 30 years back. When we started the industry in '93 in Greece, we used to build base stations that had antennas with space diversity. As a result, we were building what we would regard today as really, literally a monster on a terrace. This created an aesthetic impact that the first impact it had, it reduced the value, the perceived value of the property. Now you can imagine that you're starting an industry that is a technological champion. And we had this big contradiction. We had a business plan that was surpassed within 6 months. We had 100,000 customers expected in '93 in the next 5 years, and then we achieved that in the first 6 months. And at the same time, we had developing a threat, a perception of threat in the local community. So take this forward to today. We have about 10,000 licensed antennas, and we started with this aesthetic impact, which we realized immediately from the first few years. And we engaged actively with our friends in the Vodafone group at the time. We were a startup of Vodafone in Greece when I was working for Panafon at the time. And the experts developed cross-polar antennas. That was one trend, a technological trend. The second was the licensing trend. For 8 years since we started, we didn't have any established health preventative measures and limits. The ICNIRP decision came out in '98. We launched our network in '93. The Greek government issued a local regulation in the year 2000. The first permits that had compliance to the limits was issued in around 2001 by an independent authority. So we had a gap between legitimacy, in inverted commas, aesthetic impact, and value that we produced as a technological leader. And we ended up, to bridge the gap, the licensing gap, relicensing the network twice, because we had to relicense the network for compliance in 2006, when we had a Supreme Court decision that said that not enough preventative measures exist in order to protect the more sensitive part of the population. That's 2006. So the limits were reduced again, down to 60%. So we had to relicense the full network. What does this produce in terms of perceptions? It's not any good, I expect. And we had a licensing problem and a trust problem developing. So how we sorted it out, we first had to sort out our own house. We had to get down with the government and create a process of licensing that made sense. Until the mid-2015, the middle of the previous decade, half of the network was not fully licensed because of gaps in the licensing process. You had a license from the NRA, but not a license from the city planning authorities. The average license time, it was 2 years for a permit. And for some permits, it was non-available within these time frames. So between 2015 and now, we have bridged that gap. There is no gap in licensing, and it takes about 6 months for a base stations to be licensed. But if you take all these 30 years and what this has left in the perception of the citizen in a neighborhood, there's a big trust gap with legitimacy. It has created a legacy of legal battles. I have a few legal on my shoulder as a company representative, a few years of prison sentences from last century. So yes, you need to take the full development of our industry to understand how to build trust. So first you need to make your operations fully legitimate, but this is not enough. The state operations needs to match the speed of investment. The communication of the government needs to be ahead of the game to reassure citizens about safety protocols independently of the industry. And all that to come along with the speed of investment and the change of technologies. Because of these misalignments, we have developed a trust gap that we're trying to bridge through implementing investment in the most strict manner, having established in Greece the strictest environment of control after installation. So every base station in the country is licensed in terms of EMF compliance, and 25% of base stations are checked every year, annually. So in the last 6 years, we have tested more of the installations, and we're doubling up. And in addition to that, there is an independent monitoring system that is installed with decisions of local authorities to monitor EMF exposure 24 hours a day, around the clock. And so we have now a system that is strict in terms of licensing, strict in terms of monitoring operations after installation, and also a licensing times that make sense, and they're comparable to average European. And now we are in a position to harmonize limits. And this is possibly a successful conclusion, depending on political developments, which are not a matter of discussion in this panel, but they influence things. So we may have a happy end, but the happy end goes with trust building and having comprehensive processes and 360 look at what we're doing and how technologies are perceived, how infrastructure is perceived, and how value is created. This last comment I want to make is that the value we create in society is not necessarily visible the same way across the board. The way we see it, the way other people see it. For example, the benefit of the terminal, the services through the terminal, is not necessarily attributed to the operator. It may be attributed to Apple or to some other provider. We have to make, as an industry, more visible the value we create for digitizing our societies and the importance we can place on trust building in the new era. The new era is not the EMF era, it's the era of data management, of responsible societies that utilize in a democratic way, based on European values, the data of citizens. So we can take the experience of EMF, but we need to put it in the new perspective of what is relevant now. And the trust building relates to other areas. So my EMF experience is underlined under the perspective of today. Thank you.
Thank you very much, George. Margaret, please.
Well, basically, George said it all. We can wrap up the session. Well, to put a long story short, Austria has a history of very high EMF concern levels. At the moment, we are back, so to speak, at normal levels of the time, at the late 4G developments. When we started rolling out 5G in 2019 in Austria, our regulator gave a newspaper interview and said okay, 5G is going to be rolled out, and there will be 10,000 new antennas in Austria. The activists translated that immediately into 10,000 new sites, meaning new geographic addresses. And then we experienced an EMF tsunami, if I may call it that way. So what we did see the following 2 years was really, really bad. Yeah? They put pressure on, the activist groups put pressure on the politicians, on the local mayors, supported by about the same developments as in Germany. They used the same letters to petition all levels of politicians and decision makers. The whole thing was topped with the stories of the dead birds in Den Haag, in the Netherlands, and a number of other fake news. Did you know that we have the ability to break down bridges with 5G waves? No? Well, that was an allegation we had. Okay, so long story short, we had a list at the beginning of 2020 of about 100 communities in Austria with known activist groups, with announced info evenings that those activist groups would be holding, also with a number of our local EMF circus, sorry for not using a more friendly term, but Austria is the nucleus probably of the EMF problems because of our critical scientists, the names you mostly have heard. These were engaged in kind of roadshows where they gave speeches, paid speeches, so you would have to buy tickets to listen to them. So, and the announcement for those events would go on deep into 2021. And then COVID came. Austria faced 4 shutdowns in 2 years. So the first shutdown was in March 2020, which put a halt to all those events, meetings and lectures, with the prospect of resuming in fall, which didn't occur because we had the second shutdown in fall. So and that basically put an end to all those ongoings. What we have seen with COVID was very interesting because, just a little excursion, side mark, we know some of the activists by name because Austria is a very small country, and we found that a number of them moved over to those anti-vacciners. So same people engaged in a different topic. I'm not a psychologist. That's up to the psychologists to decide what really drives those people. I have a certain notion, but it's not a very nice one.
Some of them are paid.
Yes, some of them are paid. We have an inkling where the money comes from, following in your lead. Not that anything was really proven. So, but that really put a stop to the whole thing. Yeah? So we were able to roll out 5G, yes, with some hiccups, with some obstacles, but we were able to. And now the whole thing has, it's back to normal. We have a certain level of concerned people. We are operating a base station map where you can ask questions about the base station in your neighborhood if you want. And we're receiving about 2,000 inquiries a year, which we all which we all answer by hand because we have to answer specific questions as well. And we see the levels of EMF question that comes in here. Yeah, so there is a base of about, let's put it between 5 and 20% of very concerned to little concerned people. And some of these are ready to become activists whenever a new site goes up in their neighborhood. And it's not only new sites, but it's also the upgrading of existing sites. So whenever you have somebody working on a site, and a very concerned person sees that, you may have an inquiry on your table. But as I said, that's not really loads to be concerned. We are back at the stage where we were in the late 4G rollouts. So, yeah.
Thank you very much. Professor, do you want to add the Polish experience?
Yes, I've been talking a lot, so I don't want to take too much time. I will only say about the situation when we harmonized limits of IMF in Poland a few years ago. Previously, we had still those from Soviet Union, which were really low, and after we harmonized European one, which were much higher. And our government made it silently, mostly, without bigger explanation to the society. So immediately it caused a lot of disinformation, a lot of fake news, and a lot of problem. And in the same time, COVID came, and 5G, implementation of 5G to Poland came as well, which create more fake news connected with strange decision of our government. For example, I don't know if you know that in Poland during lockdown, it was official announcement that our forests are closed. Whole country had closed forests. No one knew why, because it seems to be the most safe place to go during the lockdown without people, but it was closed. And immediately some fake news came, like they closed forests because they want to test 5G, and they created some antennas, make like forest in the forest, to test 5G in the forest, to burn our brains, and so on and so far. Sometimes we are reaching this kind of level of absurd with disinformation and fake news. Like Margit said, it's really big problem for people, and people believe it. Really, they believe it. You have to understand that it's not something that we're talking about. It's really real problem that people believe it. Some of them spreading those information because they're paid, we know it. And some of them really believe it, and they start to work, like we call it badly, useful idiots. So they're spreading this kind of information because they believe it. They think that they're doing great thing, but they don't. So we are fighting with these problems as well.
Thank you very much. So what I got from your response is that IMF has always been a concern, but with 5G there was a new peak, let's say. And with this concern, research is needed, but this research is not always developed by people that is qualified. Right now we are having this situation of unqualified individuals making attempts to take measurements using poor quality instruments, which lead to inaccurate results. To address this, the Forum Mobile Communication Austria has taken the initiative to offer local authorities the opportunity to commission expert measurements. So, Margaret, could you share with us the background of this initiative and how it has been received?
Yeah. We have commissioned several national-wide measurement campaigns over the years. And after the 5G peak, we decided to enable communities, municipalities to get their own measurements as an instrument of communication towards the public. So what we did is we set up a program. The offer is long-time broadband measurements. So we would put up a broadband probe that measures every 15 minutes. We also created a website where you could watch the measurement values come in and create the measurement curve. The results would then be assessed by an independent accredited expert, so not by us. A report being issued and handed over to the customer. We stood not to profit from the whole program because we were selling those measurements at the base price, which is not very high for 24 hours. We would have charged 670 euros, going up to 1,000 for a long-term measurement for 7 days as a whole, so 24 hours, 7 days. We have addressed all 2,200 communities in Austria by mail last year. The response was, you would need the fingers of two hands to count them, but no real order came in. So we decided to reissue the whole thing this year, and we sent a written letter to every community in Austria. The response was even less this time. The learnings from this it's quite difficult to say. We know that communities are very hard pressed for money, even if that's not much, but we think that the public perception is not that bad nowadays, because during COVID, during the lockdowns in Austria, everybody was sent home, so home office was on the rise. Also, the pupils had to train at home, they had to do their homework. Communication with the schools was exclusively online, via WhatsApp, whatever. So they were increasingly becoming dependent on the services of mobile communication, because fiber is not available to every community in Austria. Not yet, let's put it that way. So probably this goes together with a more positive perception of the whole thing, and we think that the mayors don't experience the same pressure that they had 5 years ago when we started with the 5G rollout. So we hold the offer upright, but we will not campaign for it anymore. So if somebody's coming in, then okay. And we are thinking of now opening the offers for private person as well, because we had some inquiries by concerned citizens who said, okay, could I go and have that measurement for myself?
Thank you.
You're
So
welcome.
interesting. Then, Lisa, I know that in Australia you have like a similar situation regarding unqualified people taking measurements. What's your experience with that?
So we're seeing an uptake of people just buying instruments off the internet and using them to do measurements. So we're not sure whether these devices are calibrated or where they're sourced, or if they're in line with Australian standards. Generally, they aren't. So it's very difficult to police that or give warnings about it. We've sought some assistance with the industry has through our PANZA and the regulators in Australia to try and give some guidance on this, and we have also put statements out again warning against it. But it just is an ongoing trend. We're observing that people are sending submissions in and quoting unrealistic measurements from these devices that they've bought off the internet.
Thank you very much. Now, moving to national experiences on IMF limits. Greece is one of the European countries with the more restrictive IMF limits. So, George, how has this influenced risk perception and risk communication efforts of the Greek Mobile Operators Association?
Contradictory. The stricter the measures, the more worried people are. It's measured in the Eurobarometer consistently this way. And it's a contradiction in terms. But may I take this opportunity to say that the contradictory situation exists also on a European level. Europe has declared 5G as one of the critical technologies for digital transformation, and it clearly is. And we're debating now consistent policies to promote innovation on these networks and also to engage more actively with developing digital champions in Europe. In order to give a consistent message to the European citizen, you cannot stay only on the aspiration of more investment and faster investment. It has to be given with a message to the European citizens, one message. If you go to Spain, do you ask your local government to tell you their opinion about an issue, a health issue, or you're asking the central government? If you're in Europe, you will ask the Greek village, the village leader to give you the opinion, or the European Commission to tell you whether 5G is safe. So we need to be consistent in Europe and say to the citizens that if you need to develop trustworthy networks, they are also safe for health. And this contradiction is not facilitated by the lateness in issuing the recommendation in Europe. It doesn't do any help at all. So we need, as part of developing faster regulation and simpler in Europe, to sort out this dependency. This will also help create trust. The delay doesn't create trust, it creates uncertainty. So as Europe, we have to be comprehensive in our policies and to facilitate investment and do more good to our citizens. This is an investment in creating trust. Europe has a huge advantage in terms of culture and in terms of statutory regulations to protect human rights, to develop democracy further, to develop quality of life as a whole. Protect the health of people living in urban environments, to develop the tourist industry, and also to exploit the cultural heritage of the continent. So we need those infrastructures like 5G and the innovation on those networks and the evolution towards 6G to become a trustworthy infrastructure and choice of our citizens. We know that in our country we have about 20% of the population which is skeptics, and they are influenced by these various scenarios. And we expect this pressure to increase because of the geopolitical changes that are taking place across the Atlantic. So the best way is to move faster into a society that can have one message, not a broken down message. Thank you.
Thank you. So what I got is like we need better cooperation, better dialogue in order to build trust. That could be. I know that also Poland has some issues with restrict IMF limits. How would you how was your experience with that, or how do you perceive that public concern regarding those?
I think that I already talked a lot about it.
Okay.
Yeah, it's no reason to. I will give a floor to my colleagues because.
Of course. So now we will travel overseas again to Australia, and this year the country has updated the deployment code governing base station seating. So, Lisa, do the changes in the code has helped to address public concern regarding seating?
Well, we hope so. So our code was up for review, and this is a voluntary, an industry code whereby we're able to cite certain classes of facilities without a planning consent from a planning approval authority. So it's very important that that code is transparent, that we're achieving the goals of that and informing the community about installations, also managing concerns in a proper way and responding to them. So one of the things I will point out, and it was mentioned earlier about the precautionary approach and whether or not this actually generates concern. So the code had quite a big section on precautionary approach, and what we found was that this commentary within the code was in some way inferring that even though we were complying with a standard and using that the site was within the limits of a standard, there should be other precautions included in considerations when siting by the carriers. So this caused us many concerns, and even our regulators were saying to us, look, this is being interpreted incorrectly, perhaps this should not be in here anymore, and that we should be relying on the precautions within the Australian standard, which is based on the ICNIRP recommendations. So we actually removed the precautionary approach commentary, and that has really had no reaction within the community, and the code now does not reference any other need for precaution other than following the Australian standard. We tried to modernise it in terms of the way we provide communication, so not just sending reams of paper out and to people that aren't really interested or concerned in the matter. So we've now relied on an online portal where we've got a central page which has an EME report prepared for every installation. It also has the design drawings and other information such as photo montages if a visual impact might be of concern. So it's all there for everybody at the same time when we release the consultation. We also streamline timeframes within the code so that the local authority just has one process to follow. And it's been quite successful. We haven't had any major objections, but just generally is a more streamlined approach with less paper going out to people that don't really want to read, but the people that are interested have access to information in their own time frame online.
Yeah. So would you consider it a best practice in order for the countries to have it, like this code of practice?
Well, I would wave the Australian flag there and say that it does work very well for us. It is the main way we deploy mobile installations So all of our rooftops and those certain class of facilities and our 5G upgrades are all deployed by using that code. So it's very important to us that it is efficient but meets the objectives of informing the community.
Thank you very much, Lisa. So now I'm beginning to again to Europe, now to the UK. Hamish, the UK has also, the UK is calling on the UK government to fund the creation of a local authority, the Digital Champion, to help coordinate and prioritize digital connectivity and tackle digital exclusion. Could you please explain how this initiative works and some of the benefits it has bring?
Yes, well, in my opening remarks, I think I talked about some of the role we liked for the Digital Champion to play. It's sort of broader than just the health issue. It's also about the planning and making sure that network rollout is not unnecessarily impeded, and that the benefits of digital connectivity, which everybody's been talking about, are fully explained and explored. I think our philosophy, if I could call it like that, is that, you know, there will always be activists and scaremongers. They're just completely unpersuadable. Our strategy is to make sure that you know, their views are not scaremongering the undecided and the vulnerable, and that they are sort of, their views are isolated, put it like that. And one of the changes that's happened in the UK recently is that as part of our Wireless Telegraphy Act license, which is the licensing, we are required to comply with ICNIRP guidelines, and which was not a license condition before. We were a bit concerned that that was going to be exploited by the activists and cause us a lot of aggravation, but actually that has not happened. And the Ofcom, our regulator, does, I think it's annual, possibly biannual, sort of surveys, and then publishes the results of the surveys. So that, again, that's another authoritative reference point that gives confidence to the public that the operators are deploying as they should deploy within safe guidelines and all that sort of thing. So it's all about making sure that there's confidence that we're doing the right thing, and that people in authority, independent people in authority, such as local governments, such as local regulator, are able to say that confidently, and therefore the activists their views get very marginalised. I think that's the approach that we've been taking in the UK.
No, thank you very much. It's true that confidence is key, and having a digital champion for that is a good example. So now, I don't know if we have time for, no, the last question. And maybe audience questions. Yes, we do have time for that. So are there any questions on the audience regarding risk perception and communication? No questions? So I think that it's over for now. So thank you all, the panelists, for being here. It's been a pleasure. And see you.
Thank you, Isabel.
I will call to the stage Patricia Matran from Orange, who's the facilitator for the last session, to introduce our speaker and the topic.
So good afternoon, everybody, and thank you very, very much, Jacques, for the introduction. So I'm happy here to wake you up for a beautiful subject, which is what will happen after 5G, because of course we are all happy that we are getting into a more quiet period in terms of EMF concerns. So it's a relatively quiet period, but of course we are looking forward to seeing what happens when we deploy the next generation for mobile networks. And so I have the pleasure to call for Christer from Ericsson. He is the expert who will explain us everything on the roadmap about mobile technology beyond 5G, and providing us a first high-level perspective about EMF aspects for this coming technology. Christoph, please.
Thank you, Patricia. Can you hear me? Yeah. Good afternoon, everyone in the room, and good afternoon to all of you that are still online. So maybe I should say, first of all, that I'm, first of all, an EMF expert and not a 6G expert, so you know that. But I've tried to catch up as good as possible about what's happening around 6G from other experts in Ericsson. And I should also say that 6G is just in the starting phase of standardization. So much of what I would present today is just based on the current knowledge about what's happening around 6G. So the standards is not set yet. Things may change. I've been working in the wireless industry for Ericsson for more than 35 years now. I started at the time when the 2G was deployed. And based on my experience, it is, even though the mobile networks are being evolved continuously over time, it's at the time when we go from one generation to another that we see all these questions and concerns that we have been talking about. And believe it or not, we are now soon actually going to have 6G. So it's time for us now to start to prepare how we should address those questions that I'm sure will come. So, see if that works. Yes. So what Jack said in his introduction was that for every new generation of mobile networks, we are adding capabilities. So the first generation of networks was for voice calls. National network without no roaming and only voice calls within the country. The second generation, we added some basic data services like text messaging. The third network, 3G, that was designed to address mobile internet, that we called it, or mobile broadband. But it took some time. It took until, I think, 2007, until it really took off, when we added what we call 3.5G, maybe you remember. And then this continued with 4G, with the mobile broadband really taking off, enabling the use of smartphones and the 4G app economy and so on. And then 5-6 years ago, we started rolling out 5G, which is to a large extent a continuation of 4G, of mobile broadband, but it's also enabling the possibility to digitalize society and industry. So now the next generation, 6G, will also continue like this. It will be a network for the digitalization of society and industry and so on. And sometimes we call this a cyber-physical world that the 6G will enable. And that means that this new network will make it possible for the physical world to interact with the digital domain in real time using, of course, AI. I think this is the first time someone mentions AI today. Artificial intelligence in the network, and also to enabling like digital twins. We have an example here on the slide, holographic communication, extended reality, autonomous driving, and many other things, of course, that we have been talking about for 5G a lot, but maybe it will start happening really for 6G. What is quite amazing with this evolution is that the data rates, the speed in the networks have increased 1 million times over 30 years, from kilobits per second to gigabits per second today, or tens of kilobits per second, up to tens of gigabits per second, which is quite remarkable. And at the same time, as we heard from several surveys, the EMF exposure levels from these networks have remained relatively low, typically around 1% or so of the international EMF limits, even though we have built out these networks and improved the capacity of the networks. 5G, that was introduced in 2019, has actually grown much faster than any other generation, faster than 4G. Today in 2025, about 1/3 of the mobile subscriptions in the world are 5G already. And that is expected to double in the coming years. So the prediction here from my company is that there will be more than 6 billion 6G subscriptions at the time when 6G is introduced in 2030. Jack said 5.9 billion, I think, this morning, so it's very close. Around 6 billion. Also, the data traffic, as you can see here on the chart to the right, has grown exponentially in the last years. And lately it's mainly due to the 5G rollout. So as you can see here, the increase has been about tripled in 5-6 years. The data traffic increase has increased 3 times. And we expect it to be another doubling until 2030. So this has to be handled. There has to be more spectrum available and a more spectrum efficient technology available to address this enormous growth. And that is why 6G come in then. That I will talk about today. But I would like to start repeating again that with every new mobile technology generation, we get these questions. So it's important to have proactive information available. Exactly what we discussed in the previous session here. And that has to be fact-based, obviously, and timely and effective. And GSMA published a 5G brochure already in 2017. A couple of years ahead of 5G was really, really good. But as we also heard in the previous section, not all people trust the information from the industry. So it's very important also that there is information available from governmental authorities. And with 5G, it came a little late, but when it came, it was really helpful to have the information from governmental authorities in many countries. On this slide is an example from Ireland, from the EPA in Ireland. They published this in 2020, and it helped a lot reducing the concern in that country. Another thing that is important is that we have technical standards in place before we start to roll out the new technology. And one example of an important standard here is from IEC, the standard 6232, which is about how to evaluate compliance with EMF limits for base station products. We have the chairman of that work in the room, Christoph, and you talked about it last year. And that is, of course, very important that those standards are updated before we start to roll out the network, so we can use them for compliance assessments of the networks. Before I start to talk about the future, about 6G, I just wanted to mention a few things from the past, since I've been working with this since the shift from 1G to 2G. And technical things that we had to address when we went from 1G to 2G was the fact that we had new frequency bands, about 1 gigahertz. Before that, it was only bands below 1 gigahertz. We introduced a new digital radio interface that was creating pulsed signals. And that was also causing a lot of the concern with GSM at that time, 2G. People were concerned about the pulse signals, but also about the fact that we were rolling out more base stations mainly in urban areas to provide more coverage and capacity and using these higher bands, meaning that the base station came closer to people, and we saw concern in many countries. We heard from Greece in the 90s, for instance, earlier today. The shift to 3G then, again, there was a new radio technology with wideband signals, with rapid variations, and also new frequency bands above 2 gigahertz that had to be addressed in our test standards at that time. And the main public concern at that time was the fact that we rolled out many new base stations, and those were installed even closer to people, on buildings, on rooftops, on walls, in lamp posts and so on. That caused quite a lot of attention, as you may remember. With 4G then, there were even more technical changes, actually. We introduced MIMO for the first time, multiple input, multiple output, as you know, several new frequency bands, a new radio interface, and new products that could transmit in multiple bands at the same time. So that was addressed in the international standards, so we could do the compliance assessment of these radios. However, the perception was not so high. The concerns, as you remember, for 4G was not the same as for 3G for some reason. There were in some markets concern about perceived higher levels of EMF exposure, and also the introduction of small cells at that time was also leading to some questions. And then, of course, 5G, we all remember, we introduced advanced antenna systems, massive MIMO with beamforming, beam steering, frequency bands up in the millimeter wave range, for example. And the main concern was about beamforming, I would say, and also the millimeter wave bands. There were misinformation about these bands, that the higher levels would cause higher exposure. Okay, so will there be any EMF implications then of 6G or IMT 2030, as it is officially named by ITU, the International Telecommunication Union? So from 2023, the name is IMT 2030. 5G was IMT 2020. So there are two main international bodies that will develop the 6G standards, and that is ITU and 3GPP, the Third Generation Partnership Project, which is a consortium of regional standardization bodies and operators, manufacturers, and others. So ITU will, or they are at the moment, developing the performance requirements for 6G. That work has started. That will include a global vision for 6G and also proposals for spectrum allocations. So what ITU is doing is that they are defining capabilities that the IMT 2030 6G should fulfill. And those capabilities are enhanced capabilities compared to 5G and also new capabilities in addition to 5G. And then 3GPP will then specify the technical, will develop the technical specifications. And those will include also power classes, both for devices and for base stations that will be set then considering EMF exposure. So basically what ITU is developing, what the 5G network should be able to do, and 3GPP is going to develop the how this should be done, what and how. Those are the different roles. The framework that 3GPP and ITU is using for developing 6G is based on the 5G triangle, as we call it. 5G had three cornerstones when it was developed. The first one was enhanced mobile broadband. The second was massive machine-type communication. And the third one, ultra-reliable, low-latency communication. And this was for different applications of mobile communications. 6G will build on that, and it will enhance these three capabilities. But in addition to that, there will be added capabilities. And in this figure from ITU, they have added here, they have added integrated AI compute. So artificial intelligence will be native in the 6G network. It will be there from the start. In 5G, it has been added AI capabilities in later specifications, but in 6G, it will be there from the start. They also talk about ubiquitous connectivity, so connectivity everywhere, and integrated sensing. I will come to that a little bit more later then. But the three cornerstones will be evolved or enhanced into what they call now immersive communication, hyper reliability and low latency, and massive communication. Those are the terms they are using. But 5G is already paving the way for 6G, because there is an evolution also of 5G right now. So 3GPP has releases of specifications. Release 15, that was the first 5G release. Release 18, that came last year, that is called 5G Enhanced. Am I saying the right word now? Advanced, sorry, 5G Advanced. 5G Advanced. And in 5G Advanced, quite a lot of things that will be in 6G have also been included already. So there are improvements on energy performance, sustainability, massive MIMO, AI, intelligence in the network has been added already. So that is happening. So how does the timeline look like? Yeah, this is just an indication. We, of course, don't know exactly what will happen, but we are now in the phase of research, standardization, trials, and test beds. Research has been ongoing for some years already. In Europe, the flagship project HEXA-X was started in 2021, completed earlier this year. And there has been research, or is research ongoing in many other places around the world, in Japan, Korea, India, and the US, and so on. ITU has already completed its vision for 6G. Now they are working on the specifications and the evaluation criteria, because the ITU will evaluate proposals for 3D, for the 3D standard from 3GPP and from others some years from now. So they are now developing the requirements and the evaluation criteria. And then 3GPP has started its study period. So they are now studying and going to develop the specifications for 6G that will be evaluated by ITU and hopefully be approved as a 6G standard around 2030. So from around 2028, we will see pre-commercial networks, and from around 2030, we will see commercial 6G networks being rolled out. Overall design guidelines for 6G will be that as much as possible that work well in 5G will be kept. Changes will be made when it's motivated, when it can really give some performance benefits. And then, of course, there will be additions in order to address new use cases that ITU and 3GPP have developed. But from a technology point of view, a lot of 6G will be inherited from 5G. Many things will be very similar. 6G is not only the radio part. Now we talk about EMF, it's more the radio part that we're interested in, but it's much more than that, of course. It's the core network, it's the security aspect, it's protocols, and other things as part of the whole 6G specification. But if you talk about the radio part, then there are a number of things that will be focus areas now. And one is energy performance, spectrum utilization, which is always important, of course. Expanded device categories, other devices, not only smartphones, of course, will be supported by 6G. More capacity in the uplink will be very important, because we foresee more applications with a lot of traffic uplink from the devices to the network, like AI, will definitely create a lot of data in the network that has to be uploaded. And also these smart glasses and extended reality and all that. There's a lot of traffic in the uplink. So there has to be more capacity in the uplink. And of course, the cost should be optimized. But there is a lot of room for improvements here. And this is a one-in-a-decade opportunity to fix things that cannot be fixed with 5G. That's why we need a new generation. A lot of things can be improved over time in a new generation, but at some point in time, there has to be a new technology in order to fix things and introduce things that cannot be simply not added to an existing generation. What about frequency bands for 6G? Yeah, 6G will reuse all the frequency bands that are used already today. We call them frequency range 1, the lower frequencies, and frequency range 3, up in the millimeter wave area. But there are frequency bands in between there, sometimes called FR3. We call them also the centimeter wave band. Those are under study for use for 6G, especially the frequencies around between 7 and 8.4 gigahertz. And those are very close to the mid-band TDD that we use for 5G today. There are some discussions about using frequency bands up in the sub-terahertz range, about 92 gigahertz, but there the propagation conditions are not very good, and also the radio technology is not mature yet, so that will not happen in the early releases of 6G, as Jack also said this morning. But what is important to know is that the limits from IEEE and from ICNIRP, they already cover all the frequency bands that are being considered for 6G, and the technical standards that we have for assessing compliance also cover the frequency range up to 300 gigahertz. The waveform is of course important also, and the multiplexing technology used for 4G and 5G called OFDM, orthogonal frequency division multiplexing, will also be used for 6G. The structure or transmission of signals in time and in frequency will also be very similar in order to be able to reuse the frequencies and coexist with 5G, then, what we call spectrum sharing. But there might be some difference in some signals that are being sent continuously. 5G is extremely energy efficient, so it only transmits a few type of signals continuously. One is called the SSB, this synchronization signal block, that the mobile phones get system information from, synchronizes to, and detects the network from them. And those signals we are using those in EMF assessment by measuring those signals, and then we can extrapolate and see what the maximum exposure can be. Those may be transmitted in a different way for 6G to reduce the energy consumption even more in the network. So there might be some small things that we have to consider in the IEC assessment standards. But the limits from ICNIRP, of course, are technology neutral. So the waveform here will have no impact on the no impact when it comes to the limits. The third thing that I would like to mention is multi-antenna transmission, massive MIMO, beamforming and beam steering. That is important in 5G in the mid-band. That will also be essential for 6G. So, and that is because this new centimeter wave band that is close to the mid-band we use for 5G, in order to reuse the site grid, the existing network, 5G network, and not adding, not densifying it, we need to use massive MIMO also in the centimeter wave band. And the antenna arrays may be even larger, having more antenna elements, creating even sharper beams for 6G. But the exposure, the EMF exposure, will be similar to the exposure from 5G. And because of the more narrow beams, the average exposure will be about the same or even lower. There are a few other capabilities I just want to mention very briefly. And the one to the right here is called non-terrestrial networks. And that is something that 5G is supporting to some extent already, but it will be in 6G from the start. That means that user devices can connect to a satellite network in addition to connecting to the terrestrial network. And that will add, of course, connectivity in remote areas, in sparsely populated areas, but it will also add resilience to the network. So if there is a natural disaster, for instance, the user devices can connect to the satellite instead to the base station on the ground. Another thing is called integrated sensing and communication, and that is something that 6G will have, adding not only communication in the network, also possibility to detect non-connected objects, the position, for instance, of a car or something. And that will be important for autonomous driving, for digital twins, extended reality, and so on. That will be in 6G. And the final one is called distributed MIMO, where a user device can connect to several radios at the same time. So the base station radios are distributed. It can be indoor, it can be outdoor. And then the communication will be coordinated, and that can improve the performance and the reliance of the network. But for all these cases, the EMF exposure will be quite low because of the low power levels for the two cases to the left, because of the large distance to the satellites for the case to the right. So, and my final, I just wanted to mention a few, I wanted to mention the performance potential of 6G. This I got from my colleagues in Ericsson Research. It's based on some assumptions, of course. So these are just indications, examples of what 6G can provide in terms of performance improvements. So a few examples. Energy efficiency can be improved, in this case, up to 77% in the network, in the base stations. The same for the user devices, for the mobile telephones. The power consumption can be reduced by having different signaling, wake-up signals, so they can go to sleep, the devices, and then they wake up. The capacity and throughput can be increased up to 200%, tripled, thanks to this new centimeter wave band and using massive MIMO. And the throughput in the uplink can also be increased quite a lot. I will not go into everything. I just wanted to say that there are a lot of performance potential with 6G. That is good to know. So, my last slide now. Sorry for using more time than I had, but to summarize my presentation then. So, 6G standardization has started, and commercial systems are expected in about 5 years from now, 2030. 6G will be, to a large extent, an evolution of 5G with much of the technology reused. Multi-antenna transmission beamforming, or massive MIMO as we call it, will continue to be essential in order to enable the use of this new centimeter wave band. International standards, both the limits from ICNIP and IEEE and the standards from IEC, already cover the frequency ranges that 6G will use. There may be a need of some small updates of the measurement standards. That work has been started already. And finally, I would like to say then that there is a need, of course, for timely and fact-based information about EMF from 6G technologies, from the industry, of course, but also from national authorities, to avoid that we get misinformation and the public concern. Sorry I had to rush a little bit, but that was all. Thank you.
Thank you so much, Christer. I'm impressed by the fact that you managed to present so many things on this new technology in such a short time. So
okay.
Congratulations.
Maybe too much.
And now it's open for any question from the audience. And thank you to be still wake up, because it's end of the afternoon and not so easy. And so, yes, please, there is a question.
Thank you, Christer. It was really very interesting. I'm just curious because I don't know about that. I have not read anything about that yet. Concerning the connection with the satellites, I mean, the distance from the mobile phone to the base station, it's much closer than the distance to the satellite. Then what is the implication in terms of the power needed from the mobile phone for the uplink? Is the mobile phone going to need a lot more power to reach the satellite, or how is it going to work?
Yeah. Oh, thank you. Yeah, that's a really good question, of course, what the power levels would be for the user devices. My understanding is that that is not the case, that you have to increase the power levels compared to the normal power that will be used in the 6G network. I mean, the propagation conditions will be perfect. These satellites will be on the relatively low orbit level. So that will be the same user device that is used for the terrestrial network that will be used also for the satellite network. Maybe Jack has something to add here.
Yeah, I can just add that so far we've seen some reported data so that the received signal strengths are similar to what you get at the edge of a terrestrial network. But because of the sophisticated antennas, very high gain antennas in the satellites, that effectively compensates for that distance effect, so that the devices are designed to operate at the same maximum power, whether it's a D2D connection or a terrestrial connection.
Yeah, I also represent Eutelsat at 3GPP, and there's a number of things happening on the satellite terminals. So, at the moment, most of the work is all IoT based. It's all low data rate, and you're using existing handsets with basically crap antennas, that's very distinct from the VSAT market, which is a broadband service where the minimum antenna size is in the order of like maybe 45 centimeters square, and that's how they get around the problem of the link budget. There is work happening in release 20 on higher power UE, which is going to be going up to 29 dBm and potentially 31 dBm, which will help the low frequency devices. But the performance is still going to be, at best, you might get a voice call out of it. With a handset to a satellite, because the link budget is not there. There's very, very low level signals. If you want performance, you have to go up to a VSAT terminal, which is going to have an antenna the size of a notepad, and that's just the laws of physics. There's no way getting around it. So yes, the satellites are good at the downlink part, but the uplink is limited by the antenna on phone. And just while I've got the mic, my idea for 6G is to make antennas great again, specifically the ones on the handsets, because they are awful. They are wasting 15 dBs of link budget, and it's not on anybody's radar. And that would also reduce the EMF problem, because at the moment these devices are shoving out a lot more power than they need to because the antennas are not very good. But nobody listens to me, so anyway.
Yeah. That's another story. Thank you. It was really good to have an expert in the room that could answer this.
Is there another question? Otherwise, we have, at least I have one more. For example, relating to standardization, you mentioned 3GPP, ITU, and do you know? Can you explain a bit more how they already embark the EMF aspects in standardizing things, because there are technical standards, as you explained quite well. So they explain what the technology shall do and how it will do it, but what about the EMF?
Yeah, as I mentioned, the 3GPP will define power classes for user equipment and for base stations in the specifications, and that work will happen, and they will consider in that work also EMF aspects to make sure that the power levels are realistic from an EMF compliance point of view. But that is what 3GPP is doing. But then, of course, we need to update other technical standards, like the standard 62232 that Christoph is sharing the work of, and that has started now. That work. So we have started to think about 6G in that standard, and it's the same for the user devices. Of course, it has to be SCR and power incident and absorbed power density measurement standards being updated to take into account 6G if needed.
Yeah, and yes, I think it should be pointed out, as you say. So we have this IEC standardization internationally. This is all for those who don't know these particular standards. These are all about how we measure these exposure assessments. So the 62232 is about exposure for base stations, roughly, and you have the 62209 series for the device parts.
Right.
So we have the SAR measurement aspects, and also with increasing frequencies, we have the power density measurement, absorbed power density, and so this standardization is under preparation for this upper frequencies. Yes.
Taking this into account.
Yeah. Yes, there is another here.
Hi.
Please.
You mentioned digital twins as one of the features coming in the 6G. I think it's already a hot topic in the industry today, even for 5G. And our initial interactions with our customers on the digital twin question, it's been interesting to observe that the EMF is one of the aspects that they highlight when it comes to the interest on why digital twins, right? I'm talking about mobile operators, of course. From your perspective, EMF expert, also representative of the infrastructure industry as well, how do you see digital twins and EMF, this combination? What would be the realistic expectations on this? And how do we feed the model in an accurate way, in a realistic, accurate way? It's a very open question.
Yeah, but it's a good one.
I'm sorry.
We actually presented a paper at the conference half a year ago called the UCAP conference on this topic, that we believe that this is a good use case for digital twins, to use those. I mean, now we're talking about site digital twins. Digital twins are base station sites, because that is happening as we speak now. Many sites are being digitalized, and digital twins of the sites are being created. And of course, when we have all that information for a site, you know the antenna, you know the power levels, frequency bands, how they are located close to each other. A natural next step is then to use that for EMF compliance evaluations. So that I definitely think is going to happen, but it can be also be used for mitigation of EMF compliance challenges. So these digital twins can, of course, then also suggest how a site should be modified in order to ensure compliance. If there is another building on the other side of the street or something, will be AI in this digital twin that will propose things that you can do, reduce the power or use different features or change the position of the antennas or whatever to be compliant. So yeah, so to answer your question, I think this will definitely be an area. EMF will, I believe, be an important area for digital twins, an obvious one. Did I answer your question?
Yeah.
Yep. Okay,
Last question.
Good.
Well, good afternoon. Thank you for your presentation. One of the, let's say, technologies that is gaining a lot of attention, especially from the research point of view, are for 6G, are the reconfigurable intelligent surfaces. And what is the your view in the introduction of these technologies in the radio part of the 6G, if it will be widely introduced only to certain scenarios, and what is expected of this technology from the EMF point of view? Thanks.
I think there are different views on this. To some extent, what I presented today is a little bit of my company's view on 6G, of course. And we don't think that this will be a major technology for 6G. It may come later, may have some benefit up in the higher frequency range to extend the coverage by having reflective surfaces. But as far as I understand, it's not on top of the agenda, at least for us. But there may be different views, and the work has just started in 3GPP. We don't know how the specification in the end will look like.
Yeah, the difference is that, for example, from the academic point of view, there's a lot of interest in designing these.
Yeah.
No, just to mention, just to add that from the research and academic point of view, nowadays is a lot of interest on that, because proposing new structures with new functionalities and so on. But of course, from the standardization or from the infrastructure, the point of view could could be different.
Yeah. That's the way it works. I mean, the academic research and all these big 6G projects, they have proposed a lot of things that could potentially be used for 6G, but not everything will happen eventually. But that's how it should be, of course. It should be academia should come up with ideas, and it's terahertz bands also to a large extent an academic discussion, I would say. Okay.
So we are authorized to finish.
Okay,
Thank you again, Christer, and thank you to the audience.
Okay, so we will indulge your patience for just a short while longer to wrap up today. So I'm going to start this wrap-up session by sharing some of the results from the polls that we did. So if we could put up the first poll, please, which was about the perceptions about the scientific uncertainty that we have today. And it'll be interesting to see what this audience thinks we're at. So the question was, would you say there is more or less scientific uncertainty about possible exposure-related health risks compared to 10 years ago? And the majority think much more certainty, but it's interesting to see, I can't see the numbers because of the what's on the screen, but it looks like there is quite a significant minority who thinks that there is much less certainty, which I think is interesting to see, this 1 in 6. So we have in this room and online probably mostly a quite knowledgeable audience about this topic. And within this community of people that have participated today, there is still a sense that there is a sizable uncertainty that needs to be resolved. And as somebody like Christer that's been involved in this issue and the EMF issue since 1G deployments, I do have to wonder what more the researchers can do to reduce that perception about scientific uncertainty. So I think that's a question to people like Goliath and the other projects as they move through the next phase of their activities. So we go to the next poll result, which was about the perception about public concern pre-COVID to today. So most people are undecided. About a third said much lower, but the middle option was the main favourite response, which is interesting, and I think it reflects what we heard from many of the people on the panel. Yes, there was a peak around 5G deployments, and that in some ways the response of authorities to the misinformation around 5G and its links to COVID helped to put a lid on that peak. And we're back to the pre-COVID situation in the terms of the level of concern, the level of activity, which I think is an important message to take away, because we do see the possibility of authorities in particular thinking that there is no longer an EMF issue, and they no longer need to have up-to-date information. And that will be a mistake. We risk getting the same situation we had at the outset of 5G, where there was no statement from any authority specifically saying you did not have to be concerned about 5G, it would comply with health protection standards. And we would not like to be in the same situation as we move into 6G, as Christer has said in his presentation. And the final question was a more speculative one. What comes to people's minds when you think about what means 6G? And we asked people to have short or one-word comment. So evolution, future speed, holograms, all of those things are quite prominent, as we can see. There's at least one German word, I think, in there, but I don't know quite what it means, so I'm not going to speculate. But I do see mention of new concerns. And maybe, as we also heard when we were talking about in the risk perception and risk communication panel, some of those new concerns may not be linked to the radio frequencies as such, as more about how the technology is used. And Professor Solar mentioned the importance of providing information about responsible use of technology and how to protect yourself from things like cybersecurity and online. So thank you everyone who completed those poll questions. It's interesting to get a sense of the audience. As I said, this is a pretty specialist audience overall. We're going to, at this point, turn to Manfred, who's going to give a very brief, because we gave a lot of extra time to Krister, summary of the day, and then we'll wrap up. Thanks, Manfred.
So, thank you very much. Today we spent a very interesting days on different topics on WHO assessment of health effect and exposure of RF, risk perception and effective risk communication, addressing public concerns about the Goliath project, and EMF implication of next generation mobile technology. In the morning we had an update on the reviews from the WHO. Professor Rösli gave us insights into self-reported symptoms, human observational studies and cancer human observational studies. My takeaway was that available research suggests that RF EMF exposure below guideline values does not cause symptoms, at least short time. And available research does not indicate increased risk, cancer risk, with varying degrees of certainty. Dr. Verbeek provided us with detailed insight into the work of the WHO in this area. I understood that the certainty of the evidence varies depending on the endpoint, but in any case, we were promised that the publication of the EHC monograph will come in 2026. I think if we have EMF Forum next year, then we will have the presentation. But at least it will be, I think, a Christmas gift for 2026. Afterwards, we heard about the Goliath project, a huge project with 25 partners over 5 years. And the studies covers a wide area about exposure, neurophysiological outcome, brain function, thermoregulation, stress, but also topics like communication and concerns. In the panel discussion, we heard the various perspectives of the expert groups from Austria and Spain. In Austria, the expert group publication came out on a yearly basis, and in Spain every 3 years, but the aims are nearly the same. In the afternoon, Professor Soler presented the study International Questionnaire Survey on risk perception of EMF in Japan, Poland and Germany. We learned that the country with the most concern is Poland, but Germany protect themselves most. On the other hand, 47% of Japanese use non-protection tools because EMF is not harmful. And I have to ask my German friends, what's wrong with the headphones? I don't know. We have to ask. This part was supplemented by a panel discussion with participants from Austria, Greece, Australia, and the UK who shared their experience dealing with public concern and different approaches. The story from Greece showed in a really impressive way the long way back if trust is lost. And we have seen that COVID helped, but on the other hand, showed strange results. So my proposal is let's go into the forest to test 6G. Be careful, we heard there are people who believe it. The day was concluded with the technology outlook from Christa Ternevik on 6G. Looking into the past, we heard that the speed increased by 1 million times, but the EMF levels are still low, around 1% of ICNIRP, and we expect similar levels in 6G. For the development of 6G, a picture is already emerging of the direction. There likely a lot of development work ahead, but it is important to see that the current EMF standardization and the development of standards are already taking all these aspects into account, especially the frequency ranges. At the end of the day, 6G will be more an evolution of technology rather than a revolution. So I hand over to Jack if you want to add something at the end, or at least to close the EMF Forum.
Thank you very much, Manfred. I will only add one thing. It's something I said earlier. Base station density is your friend. Within the mobile industry, we've known that from the outset, but we've still had a problem communicating that to groups and why we face opposition around base station siting. So we heard many different approaches to addressing that public concern. We look forward to new information from the researchers about how to do that even better going forward. It seems that we still have a communication issue with even that just most basic fact about the operation of the networks. So we still have work to do. With that, thanks all the speakers for their time and expertise that they have shared with us today. I thank all the facilitators of the sessions, all the volunteers from the working group who helped develop the program for today and identify speakers. My colleagues within GSMA who've taken care of all the magic that happens behind the background so that the event works, I hope, relatively smoothly for everyone else. I hope you found it educational, informative, an opportunity to network with your colleagues and peers. Please do give us your feedback, and we will try to make the next EMF Forum better again if we can. And with that, I declare the event closed. Thank you very much.